GTA, but that's, oh, Rockstar's the publisher.
No, so then they own Rockstar. They own 2K Games. And then I made you wait 5 minutes, but they're running a bit late upstairs. I think it's what Amanda would have wanted. We like to do what Amanda would have wanted. So our first talk today, second day of the open hardware session. So Sen Hastings is going to talk about why open matters. He's got the number of props and so on. So sure, it'll be an exciting discussion.
I don't have any juggling balls. I'm very sorry.
And as I said yesterday, it's a small room, so please, get your questions ready, and we'll try to be interactive as we can.
Okie doke. Hello, my name is Sen Hastings, and this is my talk, Why Open Matters, the Cost of Transparency in 2023. So first, we have a little bit of a disclaimer. Warning, this talk contains... Oh, I'm sorry, that's the wrong disclaimer. Here we go. The views and opinions expressed in the following presentation are my own, and any resemblance to those held by past, current, future, or alternate timeline versions of my employers, affiliated institutions, spouses, or roommates is entirely coincidental. That's to say, I'm not here at the behest of anybody. This is just my words. I'm not selling anything. These are my opinions. So, to get started, this is a talk about open source hardware. Now, I'm saying this because I want to say what this is not a talk about. And this is not a talk about data centers. And this is not a talk about the cloud. I'm sorry. And actually, actually, this is not a talk about open source hardware. Because open source hardware, like in the home for general consumers, doesn't really exist, unfortunately. And I mean, I love little like open source like dev boards. Like, so Crowd Supply is basically like open source Kickstarter, and Tindy is like open source Etsy. But it's for like hobbyists and tinkerers like myself. It's like little electronic dev boards and stuff like that. What I mean is you can't go to a big box store and get like a microwave or a dishwasher that's got like an open source hardware logo on it. What I mean to say is, this is a talk about stuff that normal people would buy and interact with. And I'm only going to talk about 3 things. But I believe those 3 things deliver a good cross-section of the problem at hand. So like when I talk about a TV, I could just as easily be talking about microwave ovens or electric cars or IoT soap dispensers. Yes, that is a real thing. Or toasters or smart fridges even. So keep that in mind. This covers really anything that has a computer in it, which is everything in 2023. And this is a talk about why perhaps, maybe, those things should be a little bit more open. So without further ado, let's talk about smart TVs. Specifically, let's talk about the LG 50-inch class Cinema 3D 1080p 120Hz LED TV with Google TV, 49.5 inches diagonal. It was first announced Christmas Eve of 2012 for the 2013 model year. It shipped with Android Honeycomb, but later got an update to Jelly Bean in late 2013. And on Christmas of 2016, one of them got infected with ransomware. So the story is actually, Darren called LG customer service and was quoted $340 for a service technician to come out and factory reset the device, which, if anybody knows, on an Android phone, you can factory reset it by like holding down a couple buttons when you turn it on. So that's a little like, after a couple days and a few thousand retweets, LG quietly DM'd him instructions to factory reset the device. So that's a little funky from LG, but it's reset now, so you just like update the software or whatever, and it was discontinued in 2015. Which kind of sucks because it's been out for like 2 years. And people don't buy a new TV every year or even every 2 years. Like in early 2017, this TV is only 4 years into its, 6 to 7 year lifespan? And also, by early 2017, you have to think that the Android version that this is running represents less than 6%, so that's Jelly Bean 4.2 series, of all devices on the Google Play Store. And when 86% of all devices checking into Google Play are running an Android version, aka an API version, because they break API versions, if it's running a newer version, people aren't going to be writing apps for it. So it kind of sucks that they're not like keeping software up to date on something that's supposed to have a 6 to 7 year lifespan. But here's the thing. I lied. Kind of. Because remember, it doesn't actually run Android. It runs something called Google TV. And to understand what Google TV is, we're in early 2017 now, we have to go all the way back to 2010. Google TV is not the same as Android. So back in 2010, Google TV is announced at Google I/O as a joint venture between Google and some hardware OEMs like Intel, Sony, Logitech, and a few others, along with some cable companies. It's not Android. The press release literally says Google TV is based on the Android platform and runs the Google Chrome web browser. So the idea is that it's either like baked into the TV, the technology is baked into the TV, like a smart TV, or it's a box that sits between your television and your cable provider. So it can produce its own content, but it can also pass through content from your cable box. You can control everything with like a keyboard interface. So it was your sort of standard smart connected appliance thing. It could run Android apps. It also had a full Chrome web browser. So the idea being is that if you want to pull something up on YouTube, you literally pull up a web browser to youtube.com or any other streaming service if the streaming service doesn't have an app using Flash, because this is 2010. So it's less like pure Android and it's more like Google Chrome plus television is a good way to think about it. It had some issues. Things kind of got off to a rocky start, so there were some software issues, and Google asked their hardware partners to delay launch. When things finally did launch, they weren't super well received. So Logitech was one of the first, or perhaps the first, hardware device available running Google TV. Things were kind of bad. Like, so bad they lost $100 million, fired a CEO, slashed the prices from $300 to $100, and left the market completely. They still make nice keyboards, though. Other hardware companies also had products that seemed to be let down by the current state of software, unfortunately. Nevertheless, Google pressed onward and came out with a new software version, Google TV 2.0. So TechCrunch was not super sympathetic in their first review. They were a little bit more generous in their second review, but they were kind of let down by a lack of content. So Hulu, the Hulu website was blocked. Hulu blocked their services on the Google TV platform. Continuing to be optimistic, Google chairman Eric Schmidt claimed that most TVs would have Google TV pre-installed by like summer of 2012. And remember that around this time, Apple had already come out with their second generation Apple TV, and Roku had been around for like 3 or 4 years at this point, since like 2008. So finally, coming back around again, it's late 2012. LG is announcing their second generation of Google TV devices running Google TV 2.0. And there's our boy from the GA6400 series. Rumors had already started swirling that Google was going to pivot, but not to Google TV 3.0, maybe to something else called like Android TV. That was announced at Google I/O 2014. And oh yeah, the Chromecast had been available now for like a year. And the Chromecast only cost $35 as opposed to paying $100 for a box or $1,600 for a smart TV. So it should come as no surprise to anyone that in early January of 2015, So this article from The Verge, and basically every other article talking about this, points to this one Google Plus post on the Google TV developers group. To my knowledge, there was no other public announcement, no press release. They didn't mention it at Google I/O 2014. I can't show you a screen cap of this because, and if you try to use the Wayback Machine to look at an archive copy, it looks like this. I mean, like, seriously, it's like a white page. But here's the thing, if you open up the web inspector, there's like stuff here. It's just like not rendering properly. So if you scrape the HTML, you will actually find the post and all of the comments underneath it. So here's the announcement. So to summarize this, Android TV is fully launched. We are no longer developing Google TV software. Some of the old hardware will get updated to Android TV, but most of it won't. New Android TV hardware is coming out. LG and Logitech are not mentioned. And the last one, and this is really important, this is the last paragraph. Thank you for being passionate developers creating great content and apps for the living room. With this shift, we encourage you to transition your living room development efforts to Android TV apps and cast-enabled apps. While the Google TV libraries will no longer be available, we've made it really easy to transition apps to Android TV using familiar Android development tools as well as our new lean-back support libraries. Google TV is not Android. It had its own SDK. Google took it down. So this is not a like, oh, you shouldn't write new apps for it because like they're not going to be supported. This is like, no, like lock the doors, turn off the lights, like we're closed. Like you cannot write new apps for Google TV now. So Google killed it. Kind of. I mean, LG, the writing was already kind of on the wall. Like, you know, the tone of these is not like nobody's surprised. It's like, oh, it's officially, oh, it's, you know, it's finally happening. It's this like long, drawn out thing. And, you know, we can kind of do a little bit of a postmortem on this by going through some of the comments underneath that initial post on the Google Plus page. So this is looking really familiar. Somebody's asking about their LG Google TV running Jelly Bean. And be like, hey, you know, could we at least get an update to basically turn it into like a Chromecast? Oh, apparently that was promised 2 years ago. And then I think personally this is the best. There's literally like 70 comments. I think this is the best one. It was obvious that Google Plus TV users, me included, were going to get dumped. But why don't Google try to push manufacturers to at least give the community a way to hack the systems and try to update the devices by themselves, as is, without any warranty and conditions? We need unlock devices and bootloader keys to be able to do this. So the LG TV we're talking about was actually ARM-based. But remember, Intel was a hardware partner initially. The Logitech Review, which is the box that Logitech came out with, that was Intel-based. A lot of the early TVs were Intel-based. But no, they all had locked bootloaders. So what you're left with now is a TV that literally takes a solid minute to boot. And you have to plug a Roku into it if you want it to like function. Or, you know, it's just another statistic. So on a slightly lighter note, let's talk about something a bit more friendly. Let's talk about ice cream. Because not everything has a commercial lifespan of 7 years. Some products, especially commercial ones, can have a lifespan much longer. So here we're going to take a look at the Taylor model number C602 heat treatment combination shake and soft serve freezer. Introduced sometime in April of 2004, this machine is a semi-automatic, fully computerized, self-pasteurizing shake and soft serve freezer. It is essentially 2 machines in one. It supports up to 4 flavors of fully automatic shake goodness by 4 different syrups that are mixed into the neutral soft serve being dispensed. And a single flavor of soft serve dispensed via a manual draw handle. And thanks to its self-heating or pasteurizing feature, the ice cream and shake mix in the machine is heated up and sterilized daily. So you only actually have to break it apart and clean it with a brush every 2 weeks. No wonder then this machine is available exclusively to McDonald's. Why is that? Well, if the sell sheet is to be believed, it has something to do with the fact that like the self-heating feature like reduces cleaning and maintenance, which is pretty funny to anybody who's ever tried to buy ice cream from McDonald's because they break. Like all the time. Apparently they require frequent service visits from authorized Taylor repair persons too, which costs money if you're a franchisee on top of the fact that you're not selling ice cream. What's super weird about this is that Taylor makes all sorts of commercial appliances and ice cream machines for a bunch of other like fast food restaurants, not just McDonald's. And you know, like you don't have an issue getting like a Frosty from Wendy's, so like why is this a problem with this machine at McDonald's? Well, somebody else was asking that question too. Enter Frobot. Frobot sounds like, and was, a startup trying to market frozen yogurt vending machines. So they were using a Taylor machine, and just like basically everybody else was, and they were sticking it in an enclosure with like a touchscreen and a credit card reader, some extra control electronics. And they started having issues. They were basically having to administer these things remotely, and they kept having problems. And so what they eventually developed was essentially data logging equipment that they could use to try and sort of sniff the error codes and kind of figure out what's going on. And after a while, they realized they could sort of develop this into its own product. And they actually started reaching out to McDonald's franchisees and created like a sort of a beta testing thing. So they rolled that into a new company called Kitch. So they rolled out this whole trial with NDAs and all sorts of stuff like that. And that was going pretty well until one particular franchise owner, James Gamble, who happened to apparently have a pretty cozy relationship with both Taylor and McDonald's corporate, apparently, supposedly leaked some info. So important thing to realize is that up until about 2017, all McDonald's franchisees were required to have this specific machine. So the market for this, for a device to hook onto this machine is pretty big if you think about it. So currently Kitch has filed 2 lawsuits. The first is against Taylor, TFG, which is a Taylor subsidiary, and Tyler Gamble, the franchisee. And the second is against McDonald's corporate. So the premise of the first lawsuit is IP theft, and the premise of the second lawsuit is actually false advertising, but both lawsuits share some common ground. So the first lawsuit, it's a little corny, honestly. I mean, this is a case about corporate espionage and the extreme steps one manufacturer has taken to conceal and protect a multi-million-dollar repair racket. It's like borderline comic book, kind of. And they also reuse the same joke, this tweet from McDonald's corporate in both lawsuits. But the premise is, once again, Tyler Gamble, a franchisee, approached them to join the product trial, and during the course of said trial, fed confidential info to Taylor and Associates that was used to develop the TSSC, or Taylor Shake Connectivity Solution, which is a competing product. The second lawsuit concerns the outcome of that, where McDonald's, as part of an email newsletter, sent a message basically saying, hey, look, everybody, we're coming out with this new thing, the TSSC, it's going to be fantastic. And hey, by the way, we've heard about everybody is using this other thing called like the Kitch or whatever, and like that might void your warranty, and also we think it's like super dangerous, so you should we really think that you should stop using it. So Kitch claims this is false advertising, and the reason why a ton of their subscribers left, which tanked their business. Kitch, I think, has honestly some pretty good arguments here. But I think before we get too much further, we should talk about what the Kitch solution device, as it's called in the lawsuits, actually is. So here we can use this handy diagram from the Model C602 service manual. So the Kitch device, the basic concept is that the Kitch device sits here between the main control board, the UVC3 board, and the display/input unit, and acts as a man in the middle. It literally sniffs the bus. It sees the information being sent by the control board to the display and vice versa. And it can also actually impersonate the keypad and actually send keystrokes to the control board. Here's the device in situ. Yes, it is a Raspberry Pi with a couple of maybe specialized USB serial cables attached. We're not quite sure because it's all proprietary. So then, through the magic of the cloud and AI, you can view statistics about your machine. You can remotely control your machine, and you can receive reports if there's an issue, or you can even have the machine, I believe it's called Kitch Assist, correct itself. So sometimes the machine will throw codes for correctable errors. Like, let's say the product didn't get hot enough during the pasteurization cycle. A lot of the time, this will happen because the hoppers are just overfull. So you could have somebody stand near the machine and realize oh man, this thing isn't going to complete its 4-hour cycle because it didn't get hot enough. Well, the Kitch device is sitting there and it knows this is happening, so it's I'm just going to restart the heat cycle. Because if the machine gets worried about the product not being safe, it locks the machine out. You can't dispense a shake, you can't dispense ice cream, and you have to drain everything and clean the machine. It's game over. But the important thing to recognize here is that this does not replace any part inside of the machine. It adds kind of a layer of omniscient oversight, if you will. So it's an external device, it's an external force inflicting its will through existing interfaces. Kind of like, Fonzie and the jukebox, if you've ever watched Happy Days. It's the Kitch device is reliant on the existing infrastructure of the machine, which, because it's proprietary, could change at any time. Taylor could decide to change the design of the control board or do a new firmware update and the timing changes or whatever, and like, Kitch is dead in the water. There is an inherent danger of designing a peripheral for an ecosystem that has no explicit guarantee of consistency. What's even more strange is that in the language of the first lawsuit, Kitch positions themselves as a competitor to Taylor. Now, while this is technically correct, it's a little bit off-putting because depending on how this progresses, what sort of precedent does that set? Does Kitch want their own monopoly on AI IoT ice cream machines? If another ice cream machine OEM or aftermarket companies come up with different mechanisms for rendering the same functionality, can Kitch go after them too? So fortunately, the judge in this case actually addresses this by limiting the scope of the temporary restraining order that they sought against the defendants. Literally says, the court will not adopt Kitch's proposed order because it is overbroad and vague. For example, it would encompass imitating a firmware device or cloud platform, which in itself is not actionable unless misappropriated trade secrets were involved. It could also sweep in products independently developed or reverse engineered in a legal manner. It's very clear what Kitch's motives are. They've mentioned that they've increased prices multiple times. You know, first it was a $0 activation fee, $10 a month, $250, $30, $250, $39, and they wanted to go up to $50 apparently. And you know, they lay out their like 4-step plan for world domination here. The last thing of which is they want to develop an entire operating system that they're going to license to equipment manufacturers. This is really funny actually because in this Wired article, Kitch's CEO talks about a time he was in correspondence with Taylor back in the Frobot days. They were actually friendly with each other. Taylor sent them some machines. And so he talks about this fact that they were actually trying to get a hold of Taylor to get some help reverse engineering the bus. And Taylor was like, look, we ain't going to stop you. We ain't going to help you either. And O'Sullivan, one of Kitch's co-founders, took this as like, oh, okay, well, we can just do whatever we want. Kitch is absolutely not chill in this regard. They are absolutely like out for blood here. Kitch also makes a bunch of other claims. Like they claim that, for instance, oh, this is the error code the machine displays. It's like really cryptic and hard to understand, which sure it is until you look at the owner's manual where it tells you what the code is. Or there's this other claim here. O'Sullivan mentions a bunch of time in this article that basically they needed to access information about product temperatures inside of the machine for like food safety purposes, and the only way to access that was by using the secret code, and the secret code isn't published in the manual. So their machine that they were using in the Frobot, which is either the C716 or the C717, I'm not sure which one it is. The only difference between them is a pump, basically. What he's talking about is either the heat cycle summary, which is basically the stats of the last 366 pasteurization cycles, or the product temperatures inside of the machine, which is called current conditions. So both of those statistics are available in the manager's menu, which has its own code, 8309, okay? And that is in the user interface section of the operator's manual. Now, to be fair to Mr. O'Sullivan, all of that information is also inside of the service menu, but only because the service menu contains everything inside of the manager's menu. Kitch also says the firmware of the device has bugs because the machine appears to behave inconsistently, and the Kitch solution device fixes these. So here in the lawsuit, they outline basically like, hey, you know, here are all the bugs we found with the machine, with the ice cream machine, and here's how the Kitch device like fixes them. If the machine's auto function is disabled, it gets better. Oh, here's that feature I was talking about, Kitch Assist, that auto-correcting feature. Kitch notifies the user. Kitch notifies the user. Kitch has developed the ability to something. Here's another one. My favorite page is coming up next. It's page 27. So, like, oh, a little ahead of myself here. So, like, do we just take Kitch's word here? Look, to be fair to Kitch, there's a real problem here. Like, Taylor is perhaps incompetent or perhaps trying to enforce a monopoly or something like that, but like I really want to adopt the whole like David versus Goliath type like idea here, but the thing that we have to understand is that Kitsch is not impartial here. Okay? Kitsch wants to engineer a solution and wants to sell people that solution. And like, you know, franchise owners should want a functioning ice cream machine, not an expensive ice cream machine that then requires another expensive subscription service to actually work. Okay. We can't trust Kitsch to be impartial here. So, moving on, final thing I'm going to talk about is tractors. So, this is the John Deere 5105M. I think it was available starting sometime in one form or another since the early 2000s. And look, I think you know where I'm going with this. Here's a lawsuit from a farmer on the basis for which is that John Deere, the tractor company, has effectively created a repair monopoly by computerizing their tractors to the point where you need special diagnostic tools to figure out what's going on, making those tools available only to dealerships. Also, you need to authorize new parts with the ECU that you have to use with one of the special tools. Oh, and also, they've basically very, very highly incentivized their dealers to consolidate to the point where over 90% of dealerships are actually not like single location dealerships. So like, if you're a farmer within a 200-mile radius of you, maybe there's 3 John Deere dealerships. Statistically, they're all owned by the same company. So much for choice. And actually, here's a second lawsuit from another farmer about basically the same thing. And actually, this is a third lawsuit, fourth, fifth, sixth, seventh, eighth, ninth. 9 separate class action lawsuits against John Deere from different farmers. Like, this is absolutely 100% a thing. But to talk more about that whole like parts being like paired to the device, I want to use an analogy that hits really close to home for me, and I think hits close to home for a lot of you. So I used to fix cell phones professionally. I did so for about two years. So you know how like sometimes when you break your phone screen, it like still works? Like the top layer of glass is broken, but like you can still see what's going on and like you can still interact with it. Okay, so what if I told you that in a lot of cases, depending upon the structure of the screen, you can literally scrape off the top layer of broken glass and glue on a new piece of glass? Okay, so you can imagine this sort of cyclical economy whereby you're going to, you know, take broken screens off of phones, put them in a box, ship them to a refurbisher, and then buy discounted refurbished screens from that refurbisher, sort of like a whole core charge arrangement. And actually, in 2016, this is kind of interesting, there was a blip in the market for iPhone 6 screens, okay? They doubled in price from overseas. But we were actually, and I'm sorry to do a callback to yesterday, there were actually some local to our city, some local Russian guys who had their own equipment to do glass replacement. And we were able to work out with them, and we were able to keep our prices down, okay? You can't do that anymore because iPhone screens and cameras and I think some other stuff they're paired to the device now. Like Apple's self-service repair program, okay? If you want parts from Apple, which you can only get parts that will work if you get them from Apple, you have to give them your serial number, and then when you do the repair, you have to call them up and they have to arrange the magic handshake with Apple's mothership so that the new screen can be accepted by the iPhone's motherboard. So now it's time to ask ourselves, what is the cost of transparency in 2023? So I don't know whoever looked at my abstract. I sort of posed some bullet points as like questions almost. They were answers. So the cost is security, not only in terms of like being able to update the device, because if you can't update the device because the bootloader is locked, but also in terms of like, am I going to be able to use this device for 5 or 6 or 7 years? Repairability. again, you know, if you're locked out, if there's serialization or stuff like that, and you're not necessarily able to fix something, it costs actual money to buy new stuff when you could just be able to fix the old stuff, which for the most part is built with off-the-shelf components. And it also costs us transparency. And what transparency really is it's fear. It's fear of the unknown. It's having this carved, solid block of obsidian at the center of your life that you can't address. And that sucks. So, like I said, I'm not selling anything. I don't really have a whole lot of solutions. There's something called Right to Repair, which is sort of a movement that's pushing forward in this regard. Louis Rossmann is a MacBook repair person, but was based in New York. He actually moved to Austin. And he's spent a lot of money legitimately on trying to lobby for this. There was actually a bill passed in New York State. It basically passed with flying colors. And it sat on the governor's desk for 4 months, and then it was entirely rewritten. They took out all the language that was like, you're going to give us parts, and they added language that was like, well, only if it doesn't violate IP, and like it may not necessarily be component parts, it may just be like larger components. So we're still in the position where like, oh, the USB port on your MacBook is dead. You don't need a new USB port, you need a whole new motherboard. That'll be $900, please. I wish there was a solution for this. This is a social issue, honestly, because, you know, back in the mid-1950s, you could get whole published books full of schematics, collected schematics for different radio sets from all sorts of different manufacturers. But the tone has shifted, the tone has changed, and I think we need to start like pulling it back a little more to center. So that's my talk. This is my contact. Oh, any questions?
Questions? So I have one. If you combine like your first and second points, right? So what if there was actually something dangerous about that TV in the first example, like the pasteurization or whatever in the thing, right? Then do you think there would be a, consumer, someone would care more? There would be regulation then because it was somehow dangerous in the consumer home versus, oh, it's a TV or something like that?
Maybe. What's so funny about the Kitsch device, and Kitsch actually argues this, is that, first of all, because McDonald's corporate argues basically like, oh, this is dangerous. It could cause the machine to operate when, because somebody is remotely controlling it while you're trying to work on the machine could just come alive and spew hot, ice cream all over you.
Yeah.
And
a mess.
It literally says in the service manual, like, unplug the machine before working on it. And also, like, when you open the door, there's interlocks. So, like, things get de-energized and it can't hurt you. So the whole idea that there's kind of any danger in the first place is a little bit bogus. I would hope so. Maybe.
Yeah. When I guess I was thinking about it in a potentially positive way, which is therefore those regulations could be used to kind of guide, if you will, the manufacturers and so on into better behavior. Rather than just the laziness that
it's hard because manufacturers, large organizations, they're essentially they're organisms, and when you scare something, when you scare an animal, like it doesn't always necessarily behave how you would like it to behave. So I would hope so, but I don't know, unfortunately.
Other folks, yeah. Just a second, if you can just wait for the mic.
The microphone.
I think it's quite well known at this point that opening up, especially things like software, and the classic example is cryptography. If things are viewable, then they have fewer bugs, and people often won't trust them unless they're open. So if there was a case, I mean, I don't know whether there is a case of this. I mean, so you had an ice cream machine and it had a bug in it, and the bug made it not do the pasteurization properly, and people got sick.
Oh, yeah.
Then wouldn't you be able to argue that not opening this stuff up is in fact a public health hazard potentially, because the bugs like that would be more likely to be caught if it were
Yeah,
open?
you would think so. Again, what I find particularly egregious is the fact that it's like Kitch claims this machine has issues, because they're always watching it. They're always seeing what it does, and they make claims that it's like, oh, the target temperatures drift overnight and blah, blah, whatever, stuff like that. And we've noticed that under these circumstances, the machine does this thing, and it's all redacted. It's all redacted, which is like, how is this? And so it's like, this isn't like making, like, you know, Kitch is not doing this out of the goods of their heart. Like, Kitch is doing the American, you know, find a problem and find a need and fill it. They found a problem and they're fixing it, but they want a monopoly on fixing it now, which is like not something that we necessarily do in the open software world, which is a little disappointing.
I see, yeah. So they might be a lot more successful. Well, it would be a lot better for the public if they made all this stuff public,
Yeah,
of course.
I mean, again, what the public really needs is a functioning ice cream machine, not a monopolized Band-Aid solution.
All right, let's take one more question, and if you want to come up and get connected. And one more question, somewhere. Yep, over on the far side. Thank you.
I really thought that Kitch were the good guys in solving the ice cream issue.
I thought so too. Like, I really was going to basically take the whole narrative that a lot of the news organizations were taking, but then I started reading their lawsuits, and it's so hard because it's just like in real life, everything's really muddy. But the best way that I can think of this is it's like a smaller snake fighting a bigger snake. Like, nobody's really, you know, nobody's really 100% clean here, unfortunately. Nobody has pure altruistic reasons for doing this stuff. Money is involved, unfortunately.
So that wasn't quite my question, but it was more of a statement. But the question was, I think in the UK and worldwide, historically, with car manufacturers, they always went after the guys who built aftermarket parts. So anyone who's ever serviced a car knows you can buy different brands of oil filters, et cetera, et cetera. With that precedent set for the likes of the Deere tractor company, the Taylors of the world, would that not be a template to follow, or a standard?
You know,
set?
I would. Yeah. I mean, you know, you wouldn't want people modifying and souping up their vehicles like moonshiners back in the early aughts, early teens, because then you'd get NASCAR. That's where NASCAR came from. Yeah. Unfortunately, it's actually changing in the car world too. Like, especially you take a look at Tesla, and things are getting pretty locked down. Like, I don't know if you heard about Simone Yetch. She's a YouTuber. She converted her Tesla into sort of a pickup truck, and she was very, very afraid that she was going to get locked out of the supercharger network for doing that, which is very disappointing, honestly.
All right. Thank you, Sen.
Thank you.
All the great stories. Let's get hooked up.
Oh man, I forgot to be nervous.
The mic is good. Yeah. You might want to take that. Sometimes it. Like, why is it clicking?
clock at the.
No, but I have a 10 minutes, 5 minutes. Is that enough, or?
Yeah, in an ideal world, I'd like to know as we go along. It doesn't matter. It's fine.
No, it's fine. I can tell you 10 minutes.
Yeah, I'll just not write it down there.
I'll use your.
Decapitate you.
Yeah, sorry. Okay, good. So our second speaker this morning, Andrew Katz, is going to talk to us about licensing in the open hardware space, and maybe there's some good news. I don't know. Good news, bad news, whatever you bring us, we'll accept it.
Yeah, fantastic. Good morning, everyone. Thank you very much indeed for inviting me along. I'm Andrew Katz. I am a lawyer, although before that I was a software developer, but I've been advising on free and open source software for over 25 years now, quite scarily. And I've also been quite heavily involved in open hardware as well. So what I'm going to be talking about today is really talking about what do we mean by open hardware. And the first question is, do we call it open source hardware or open hardware? To be honest, I don't really care that much. Then we're going to talk a little bit about the licensing context. We're going to talk about some of the differences between licensing open hardware and open source software. And then we're going to delve a little bit further into the concept of open. What do we mean? Is there a distinction between openness in hardware and openness in software? And I really need to find some new terminology for this. So if anyone comes up with any ideas, then that would be really helpful. But there's a concept of softness in hardware. Some sorts of hardware are harder than other sorts of hardware. So we have soft hardware and we have hard hardware. But I'll talk about that a little bit later. I'm a lawyer, so I tend to talk about things like liability, but don't worry, this one will be pretty quick. And then we'll talk about community dynamics. We all know that community dynamics are very important in the world of open source software. Do they work the same way in open hardware as they do in open source software? And then I'll talk a little bit about business models. Now, we've got a relatively small number of people here today. If you've got any questions while I'm going along, feel free to stop me, but obviously we'll have to make sure that we get a mic to you first because we're being streamed.
Do we have to say objection?
Yeah, it's overruled. It's overruled. So very, 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 very happy to do that. There's a lot to cover, and we've got a limited amount of time, and I do enjoy talking, so I'm going to have to try to summarize this. I'm not going to be able to go into any of these topics with the depth that I would ideally like to. So let's start with the question, what are we actually talking about here? This can be a problem because people come to open hardware with a preconception of what they're talking about, and it tends to be the particular field that they're in. Many people think about, when they're talking about open hardware, for example, they will think about electronics, so circuit boards. And, there's nothing wrong with that at all. More recently, you'll find people talking about silicon chips, open silicon. So, for example, the open hardware group, they're really only interested in open silicon, even though their name suggests that they cover the whole of the spectrum of open hardware. Then you can have sort of more physical items, so things like cases and racks and furniture to go in data centers. So that's the sort of thing that OCP, the Open Compute project, is interested in. And then, of course, you can have mechanical devices as well. You can have things like motors and engines, or you can have means of transport like cars and boats. And actually, the first piece of open hardware that I got involved with about 15 years ago was an open source car. You can have 3D artistic works. They can be physical, but they don't actually need to have any particular functionality about them. They can just be there because for aesthetic reasons. And any sort of 3D printed works, could potentially be open hardware as well. But they don't even have to be solid. I mean, there's no reason why fluids couldn't be open hardware as well. So you could be talking about particular gas that you use for a refrigeration device, or you could be talking about hydraulic fluid, or you could be talking about a drink like cola. Open cola is a open hardware knockoff of Coca-Cola. So whenever I've been working on open hardware, and I've done a lot of work in licensing, I try to think of the whole potential spectrum of everything that we could be talking about in open hardware, not just one particular area like open silicon or circuit boards, for example. So when you're defining openness in terms of hardware, the Open Source Hardware Association has some guidelines, and they're based on the 4 freedoms, which, if you know free and open source software, you'll be familiar with those, and also the 10 OSI criteria for the open source definition. So the preamble to this says that open source hardware is hardware whose design is made publicly available, so anyone can study, modify, distribute, make, and sell the design or hardware based on that design. So anyone that's familiar with the 4 freedoms of the Free Software Foundation will see nothing peculiar about that at all. So here's an open question. I'm not going to answer it. Can a chocolate cake be open hardware? So is the recipe for the chocolate cake a design document? Right, just bear that in mind, and then we'll talk through this a little bit, because we're going to get onto the legal bit now. So open source software is very much protected by copyright. Software is protected by copyright, primarily. There are other intellectual property rights patents that are involved as well. But primarily when we're talking about open source licensing, we are talking about copyright licensing. And therefore, to do anything with any software, to modify it, or to run it, or to distribute it, or to sell it, make it available for sale, any of these things, you're going to need some sort of license under copyright. And that license can either be a proprietary license, like the sort of license that would come with a copy of Microsoft Word, or it could be a free and open source software license, for example, as with LibreOffice. Is the same true of hardware? Now, there are quite a lot of challenges as far as intellectual property is concerned when it comes to hardware, because potentially it's covered by a much broader range of intellectual property. Now, I'm not going to have time to go into this in any detail. So there may be copyright involved in the design itself, if it's a design drawing, for example. There could be patents. I mean, patents can apply to software, but they tend to be much more prevalent in the world of hardware. There are various other aspects, such as design rights. There's registered design rights, unregistered design rights. There's even sort of specific IP that is a sort of creature of statute that's designed for very specific areas. So there's things like plant breeders' rights, more specific to open hardware, probably. The semiconductor topography mask rights over the particular layout of a silicon chip. There's also database rights, which is a right particular to the EU and the UK. And the list goes on. So if you're looking at open hardware licensing, you need to think about a broader range of intellectual property rights than maybe people generally do when they're thinking of software. Now, anything that you do with software is likely to need a license. As I mentioned before, if you're running it, if you're modifying it, if you're distributing it, if you're making it available, all of these things would be an infringement of the copyright in the software unless you have a form of license. But with hardware, that's not necessarily the case. You know, if you pass a hammer on to somebody else, you don't need any form of IP license in order to do that. So a piece of hardware can be used and deployed very frequently in a way that doesn't involve intellectual property in the same way as it would with a piece of software. And this does have some implications from a licensing perspective. So bear that in mind. Now, if you're applying licenses to open hardware, what do people use? And if you imagine, the fundamental question is, what are you applying the license to? And the answer is, it is the design, which could be design drawings, or it could be a circuit board layout, or it could be the files that you need to create a bit stream for an FPGA, for example. So sort of Verilog code, something like that. I'll talk about that in a little bit more depth later. So when people are opening up hardware, they will be applying a license to it. And typically, they will start with the sort of licenses that would apply to open source software. So people have taken hardware and they've applied licenses such as BSD, MIT, Apache, and even GPL to their hardware designs in an attempt to open them up. Sometimes content licenses are used, so you'll be familiar with the Creative Commons suite of licenses. There are plenty of open hardware designs out there that are opened up by the application of a suitable Creative Commons license as well. But both of these types of license, they do have some shortcomings as far as open hardware is concerned, because they're not designed for open hardware. Open hardware has certain characteristics that are not the same as software. For example, many of these licenses in Apache, for example, GPL, they talk about source form and object form. Is it entirely clear what we mean by that in the world of open hardware? And they also tend to focus very much on copyright, and there may be some reference to patents in there. Apache has an explicit patent license in there. GPL does, depending on which version you're looking at. But because they're focused on software, they don't look at all of the other range of IP rights that I talked about earlier, so that can be a problem with them. Creative Commons licenses all explicitly exclude patent licensing, so no Creative Commons license will grant a patent license, so that can potentially be a problem as far as openness is concerned as well. So there's a number of hardware-specific licenses that are out there. I've worked with CERN to develop a suite of open hardware licenses. And that comes, like the Creative Commons, in a number of different flavors. There's a permissive version and weak and strong reciprocal versions. So they're sort of broadly supposed to be equivalent to Apache, GPL, and probably LGPL. But that's a sort of very, very broad description there. Solderpad is another license that I've written, which has been adopted by the Open Hardware Group, and that's very much based upon Apache, but just with some of the terminology tweaked a little bit so that it doesn't have this issue between trying to define source form and object form. There's the TAPA license, and OCP have 2 licenses as well, although we can have an argument later about whether they actually count as fully open or not. But I won't go into the details of that now. So, open source licenses, they're not unlicensed. Something that's available under an open source license, it's still subject to a license, and there are some conditions. And those conditions, they can be very easy to comply with. So they can be just a question of retaining things like attributions and providing copies of licensed texts and so on, which don't cause any particular problems with implementation. It's very straightforward. Reciprocal, copyleft licenses, share-alike licenses, whatever you want to call them, they do create more of a problem because they have placed some sort of obligation on the licensee to make sure that when they redistribute whatever it is licensed to them, they also have to apply the same license. The scope of that can be problematic, and we'll talk about that in a second. But one of the other issues is because you are always applying a license, the only way that you can make any of these obligations apply is through a condition to that license. And even if it's a simple condition like having to provide an attribution, the only way that you can enforce that is to say, unless you provide the attribution, then you're not licensed to do what you want to do with this particular design. Now, we've already established that in the world of hardware, intellectual property has fewer opportunities to impinge on what you're doing, and every opportunity to impinge on what you're doing is an opportunity to apply a condition, and therefore to make sure that these particular obligations stick. So that's one particular problem that you may have with open hardware, is there are not enough opportunities to make these obligations stick. And there is also a problem, particularly with these reciprocal type licenses, is how you deal with a combination of more than one component. So if you've got a particular component that's under a reciprocal open hardware license and you plug another component into it, does that mean that as soon as you plug the other component into it, that other component also has to have its design released under the same license? And that could apply to if you have an open source wheel and you bolt it onto a car. Does that mean that the whole of the car has to be released under an open source license? So this is something that is a challenge to actually define how that might work. So those are some challenges around licensing. There are also economic issues, and I'll go into those a little bit later. I probably won't have much time to go into them at all, so there's a link to an article. This will be published, but that does explain some of these issues in greater depth. The other question is, how open does open hardware have to be? So I've touched on the component point before. So if a component's design is released under open hardware, does that mean that you have to provide the design documents for everything to be created from scratch? And if you're thinking in terms of a circuit board, for example, it's quite easy to automatically visualize what you mean by a component, right? It's going to be a transistor or a capacitor or a resistor, or so on. This is not how things work with software. If you've got the full source code for a particular component, then you can compile the component, and if it contains any subcomponents, then they're also going to have to be appropriately licensed. There's no automatic cutoff point at which you say, these dependencies, you don't have to get a license for them. But of course, with open hardware, we're talking about a whole bunch of different types of open hardware. So how do you come up with a universal concept that says you only have to provide the design documents to a certain level of abstraction, and then below that level we can assume that these components are automatically available and you can acquire them from somewhere. So this is something else that we've been struggling. But then this impinges on the question of, if you don't provide all of those information about how to make the components, does that mean the design is truly open? So this is a much vaguer question in the world of hardware than it is in software. So in software, you can pretty much always claim that if the software is released as source code under a license which is approved by the OSI or the Free Software Foundation, then it's open source or free software, as the case may be, probably both. That's really as far as this goes. With hardware, the question is much more complex, and the Open Source Hardware Association goes further. So one, which is sort of obvious but actually doesn't apply to software, is that the design must be made public in the first place. With open source software, that's not actually the case. It's perfectly possible for software to be, well, free software at least, if it's made available under the GPL and you just happen to pass that code privately to somebody else under the GPL license. It doesn't have to be made public. Of course, the recipient is perfectly entitled to do that if they want to. If you've had difficulty understanding some of the parts of GPL version 3, which I certainly did, the reason for some of this convoluted wording is quite often to allow this private distribution. But anyway, that's sort of by the by. So you also need to make sure that the interfaces to any software they must be documented or provided under an OSI license. So many items of hardware will contain software themselves in terms of firmware. So basically what it's saying is ideally all of the software is available under an open source license. If it isn't, then at the very least you must make sure that all of the interfaces are properly documented. And if you wanted to get it certified by the Open Source Hardware Association, they do certify designs, then you need to use open components where possible. So there's no prohibition on using proprietary components, but if possible, you have to use non-proprietary components. Right, okay, I'm going to talk very briefly about liability. Open source software licenses, they pretty much all of them will contain a very extensive disclaimer of liability in there. The same is the case of open hardware licenses. One question that some lawyers really don't like to tackle very much because we're not sure we are going to like the answer is how enforceable these disclaimers are. Most jurisdictions have some legislation that basically says blanket disclaimers, especially for certain things covering such things like sort of death and personal injury. They're not automatically effective. There are good arguments why a judge might be prepared to say in this case they're fine, largely because you're getting the designs for free. So why should the developer suffer under any liability? but it's a potential legal debate there and something that we need to think about. Certainly, we don't want individual developers to be found liable because that would be dreadful. It would have a huge chilling effect on community involvement for any particular project. And you always have this complex interaction with regulation as well. I mean, fundamentally, consumers are entitled to receive safe products. I don't think anyone's going to disagree with that statement. So that means somebody in the supply chain is going to have to carry the can. And the question is, who is that? And we just want to be very careful to make sure that it's not an individual developer. There is some corporate entity with sufficiently deep pockets or sufficient insurance who is able to accept liability. And of course, there are areas which are fairly heavily regulated as well that only allow certain products to come onto the market if they have been through certifications or they meet certain standards and so on. That's particularly true of medical, pharmaceutical, and automotive industries. So there is a tension between opening a design and allowing people access to it, and as much as they can to reduce the friction to enable them to participate in open development, but at the same time making sure that dangerous items are not released to the public. And so this is something else that is not settled, and there are a number of techniques that we're working on that may help to deal with that. But it does suggest a possible business model, which is where an organisation can release the designs for a particular project under an open license, but then at the same time say, okay, if you want to be the entity in the supply chain which makes it available, for example, as a medical device, then we will provide you with the dossiers, the information that is necessary to submit to the regulator to do that, and we can charge for that. So there's a possible business model there as well. So let's talk briefly about hardware and community, and this is where we get, yes, sorry, I have a question. Can we have a mic? So I'm sorry I'm going so quickly. So there is a large amount to cover here. So questions are welcome.
So just on the last slide, I suppose the question is, has anybody actually tested liability in court? Because that's the real test.
Not that I'm aware of. Right. And it's very true of sort of open technologies on the whole, which in many ways is a good thing, is there are very few sort of court cases that we're aware of. Either A, because they tend not to happen in the first place, or B, because if they do happen, they're settled before you actually get to the stage of litigation. But there's been quite a lot of debate about it. Yeah. So I was involved in a European Commission study on the impact of open source software and hardware, which was published at the end of 2021. And we looked quite closely at the different sorts of open hardware and how they might be mapped. This is where this sort of soft to hard spectrum comes in. So I will just explain this cycle very quickly. So in any sort of development, you're going to have a design phase, which is where you design the thing that you want to make. Then you build it. If you're talking about software, that can be as simple as running it through your tool chain, compiling it, and then you test it. Does it work or not? If it doesn't, then you change it back to the design phase. So you get this cycle of design, build, test, design, build, test. When you're happy with it, then you'll go to a productize phase. And for software, that can be really simple. It can be just a question of making the binary available somewhere for people to download, or putting it part of some sort of package that they can put onto their system, and so on. If you're talking about something like a car, then the productize phase is obviously going to be dramatically more complicated. So this is one distinction that we have between software and hardware. So issues that we have with development, I mean, in software, the development tools are all in the digital domain. So things like GCC, the GNU Compiler Collection, they're generally free. They're free software themselves. They're available to anyone. So the barrier to entry is very, very low. You can develop very complex software on cheap equipment. As long as you've got an internet connection, you've got a basic PC, you've got Linux, you've got these tools, then you can really get involved in developing any open source software project. You can get involved with that if you want to. Hardware can be very, very different. So if you think about something like an open source car, I mean, first of all, you're going to need a whole bunch of CAD, CAM software. That's going to cost you a lot of money. There may be simulation software that you can use to do things like model the airflow if you're doing aerodynamic testing, or the effect of the suspension and so on. But I mean, that's likely to be extremely specialized, extremely expensive software. You're going to need a whole bunch of physical tools like lathes and milling machines and presses and goodness knows what else. Shipping a car around the world is a non-trivial activity. You're going to need a big space, and it's going to have to have environmental constraints. And that may include things like having ultra clean air, for example, particular temperature, and so on. And then, of course, there's much more variability in the cost and quality of feedstock that you could be using. There are many different grades of steel, for example. If you're building software, you're building it out of zeros and ones. Zeros are zeros, ones are ones. They're all the same. That's not the same with steel or lubricating oils or whatever you have. So there's big differences there as well. So if we go back to the sort of design, build, test cycle again, I mean, what you can try to do is, rather than having to actually build a car every time you want to test it, to a certain extent, there are, as mentioned before, there are some sorts of software that you can use to simulate various aspects of it. But there's no software yet that will let you simulate an entire car so that you know that this thing is going to work. And then you can send it off to some magic 3D printer that can use loads of different materials at once and create the car. That's not going to happen. So even though there are some sorts of open hardware where you can do an awful lot of the design entirely in the digital domain, that's by no means universal. Now, we were talking about an open source car, for example, but some sorts of hardware project, it's much more like operating purely in the digital domain. It's much more like developing software. So for those of you who are not familiar with FPGAs, they're a sort of chip called a field programmable gate array. And basically, what you can do is you can reconfigure it to be a whole bunch of gates that can fulfill all sorts of different functions. It depends on the configuration, and I'm deliberately avoiding using the word programming here, although people often do, because that's going to confuse things. But what it's doing, you can actually change it into a different chip, effectively. It can be a processor, it can become a memory array, it can be a USB interface, whatever the configuration is that you feed into it. And the way that you create that configuration is by writing code that looks very much like software code in a language like Verilog, and then feeding it through a tool chain, and then it turns it into a bit stream, which is basically what the string of bits that you feed into the chip, and that configures it to do what you want to do. So is it hardware? Yes, but it's very much more like software. A lot of the development process is very similar to the software development process. And this is typically what I will call soft hardware, because pretty much everything that you want to do with that chip, you can actually do it in this cycle, in the build, test, design, and then you can simulate it, and when you're happy with the way it simulates it, and you can simulate all sorts of physical characteristics, you can simulate the timings, you can simulate voltages on the various pins, etc. That's all possible entirely in the digital domain on your desktop, and then you can productize it by plugging it into the FPGA. So it's much more similar to a software development process than it is to developing hardware. So to that extent, hardwareness does matter. And we found that hardware projects that operate much more completely in the digital domain have all of these very low barriers to entry, low friction. They operate much more like software projects in terms of the dynamics and in terms of the communities that are potentially built around them. And that's because you can use the same tools, GitHub and GitLab, And the one problem that we have at the moment is that a lot of the tools are proprietary and they can be very, very expensive. So an example of a company that's doing a really good job in terms of open source tool chains is Chipflow, but we've still got a fair way to go before that particular barrier to entry is removed. But nonetheless, we find that the dynamics that operate in this soft hardware world of open silicon are much more similar to open source software development than they are to other sorts of open hardware. Just to give you a background, so the cost to replicate a Linux kernel is 0. I mean, you just take the binary, copy it, and you've got another binary, right? It costs fractions of a penny to do that. The cost to replicate any car, even if it's an open source car, that's going to cost you hundreds of thousands at the very least, because you're going to have to completely remanufacture it. So this is part of the dynamics that come into effect when you're thinking about the economic impact of open hardware. But if you want to replicate an FPGA, then it's going to cost you, I mean, that's the cheap end, $1, but the cheapest FPGAs will cost $1. You just feed your open hardware bitstream into it, and it does exactly what you want it to do. Clearly, different FPGAs have different capabilities and so on, but that's at the low end, it's $1. I mean, you're sort of talking about sort of $10, $15. You're talking about a pretty advanced FPGA there. So again, this is something that is much more similar to the software regime than it is to harder hardware like making a car. So what tends to happen is that soft hardware can be openly designed. And by that, I mean that because you can make the design available on GitHub, GitLab, you can develop a community around it, and they can have spent a few dollars on an FPGA test board. It's very inexpensive for them to be involved in the whole design and development process, in much the same way as they would be if they were developing open source software. Hardware that is harder tends to be made on a release when ready basis. So this basically means, if we were as part of the open source study, we were talking to Arduino, even though, those of you not familiar with Arduino, so it's a sort of little circuit board that's got a microcontroller on it, and you can basically use it to control 3D printers or heating systems, or it's just a very handy multi-purpose little device that you can program to do things and send signals and make things happen. And Arduino, all of their designs are open hardware, so there's no problem with taking the designs and manufacturing them yourself. People tend not to, because it's easier just to pay the relatively small amount of money just to buy an actual Arduino that's been certified by Arduino. But there isn't a community around designing the Arduinos themselves. All of that design is done in-house, and then when the product is ready, it's made available. Now, there's a huge community outside that of using Arduinos in various contexts and circumstances, but not actually in terms of the development of the underlying piece of hardware itself. So we found as part of the study that the most interesting and active areas in open hardware at the moment are those areas that can take advantage of all of the open source advantages that you have with software, the low barriers to entry, the low friction in terms of the development cycle, and so on. So the most active areas in open hardware currently are definitely in open silicon, because they can take advantage of these characteristics. So Sci5 is a good example, US company, which has received a total of $365.5 million in funding. And they produce processor cores, which are based on RISC-V. Swerve is an open source core that's been released by Western Digital. That's also doing pretty well. It's embedded in a lot of their sort of disk drives, for example. I mean, there's a whole bunch of other initiatives out there sort of releasing open silicon. So if you look across the whole swathe of open hardware, most of the activity at the moment is very much in the area of open silicon. And they're not just processors, cores, and interfaces. There are other open silicon activities going on there as well. So thinking in terms of business models, there is no one business model, but bear in mind that whenever you're selling hardware, there's also the possibility to sell atoms as well. If you're buying an Arduino, the chances are you're not just going to take the design and make it yourself. What you're going to be doing is you will be actually buying the board. And Arduino's model is basically to sell its name and reputation. There are plenty of Arduino-compatible boards that are being developed using Arduino designs coming from the Far East, for example. That's entirely legitimate. But Arduino itself is not too concerned about them because they're relatively inexpensive anyway, and they believe that their name and reputation is why they still have very good ability to sell the hardware that they make. Sci-Fi sells enterprise versions of their cores, so there's open source versions of the cores, but then there's also enterprise designs for which you will have to purchase a special license that has additional capabilities as well. Western Digital uses its Swerve cores to build on foundational technologies. So we were talking about the chips inside the disk drives. And you can provide open hardware consultancy and training, and you can also sell a regulatory dossier as one possible business model. I sort of touched on that earlier. So, in summary, open source hardware is much less mature than open source software is. There are similarities between them, but there's also big differences, and we're waiting to see how that one plays out. Some of the basic definitions are not very easy to map from one area to another, so that's something else we need to be aware of. And the licensing situation is more complex in many ways, partially because there are many more intellectual property rights that can infringe on hardware. But the great advantage that we have is there are many fewer licenses. The number of dedicated open hardware licenses is pretty small compared with the hundreds of open source software licenses. That's a good thing. It's dangerous to assume that what automatically works in open source software works in open source hardware, but the softer the hardware is, the more likely it is that you can translate something from open source software to open source hardware. The physical world has much more of an impact with open source hardware, especially at the hard end. You're going to need factories and so on if you're making cars. And the only thing we do know is that we don't know very much, so we need to do significantly more study. So thank you very much indeed for listening to you. Appreciate your attention. Apologise for having to rush through that so quickly. Have we got time for any questions?
We've got time for 2 or 3 questions. Here, yeah.
There we go again. So are there stuff you actually just can't copyright or license? Because you used recipes as an example earlier.
The chocolate cake. Yes.
Recipes themselves aren't copyrightable. It's the things that people put around them that are.
Yes, I should have. Yeah, that's one thing I sort of wanted to talk about that a little bit more. So, I mean, at its most basic, a recipe is a list of ingredients and an instructions on how you mix them together and how long you cook them for, and that in itself is unlikely to attract copyright because it is basically just a list of facts. It's like, if you want to make this chocolate cake, you've got to take these materials, combine them in this way, cook them for this long at this temperature, and so on and so forth. Copyright protects the expression of an idea. So if the recipe sort of says, this is my great aunt's recipe, and she used to, if we've read any recipe books recently, they all contain this extremely irritating waffle about about great aunt and chocolate cake. That's all copyrightable, which is cynically, you could argue that that's why it's in there in the first place. But if you can distill it into, what great aunt did was, she got this much flour, this much sugar, this much chocolate, mixed them up and bunged them in the oven, then that part of it isn't going to be copyrightable. And it does cause a problem because we have questions like if you have a sort of necklist that you're using to generate a piece of electronics which sort of sets out, which bit of the capacitor goes to which resistor and sort of and so on. So that's a database. You can see it's a database. Is it subject to database right in the EU and the UK? Yeah, sort of not. So there are these sort of grey areas that we're not entirely sure about what is protected and therefore what the licenses can impinge on.
So chocolate cake, no. Any other kind of cake?
Yeah.
Go ahead.
Hi. I had a question about, I'm interested in the role of simulation perhaps in facilitating sort of open source activity, because I think if you had a chip, say that people were interested in chip design or ASIC chip design, and they had a simulator which was, reasonably faithful that in the sense that if you put in a new design, it's going to tell you it would make a better chip. If you did embody it physically, you could imagine that the barrier to entry to get involved in that kind of thing would be quite low. But of course, then there's this sort of extra step. So I was just wondering. To me, the obvious thing that would be perhaps less ideal would be that the people wouldn't necessarily get the use of the better thing unless somebody was good enough to decide there's enough of a market to manufacture this chip sort of at a reasonable price.
Yeah.
But are there any examples of that where kind of they spin up these communities and they're designing things which just exist in their imaginations, or they would work on simulators, but then? Do you understand the question, or is it?
Yeah, no, I do very much so. And the trouble is, I'm not a chip designer. Yep. So the answer to that, when I speak to engineers, and there's a question of how good simulators are in the first place, and obviously if they're pretty good, they're going to cost an absolute fortune and huge amounts of money. Yeah, exactly. If I talk to somebody and it turns out that they have a connection with one of the tool chain manufacturers, they're going to tell me that these simulators are absolutely superb and you can do absolutely everything in the digital domain, and you just press a button and some bits disappear over to China or Taiwan, probably, if you're talking about ASICs, and then depending on the current political situation, you'll get a box of several 100,000 chips back that will work perfectly. If I talk to people who are more used to putting chips together in the open hardware domain, they're going to basically say, no, it doesn't work like that, mate. So it's a really good point. But the key assumption that we're not quite sure. Yeah, exactly. And I think it's inevitable that over time, these tools will get better, as they have done in the world of open source software. But maybe I'm being a little sort of over-optimistic in terms of thinking how long that's going to take to happen, because it's a very complicated issue.
Last question, the mic there in the back.
So there's a number of different licenses for open hardware.
Yeah.
Permissive, weakly copyleft, and strongly copyleft. Has any of this ever been tested in the court of law? I've not seen any.
Not as far as I know. No. This is a problem that we have, as mentioned earlier, behind that. The whole of sort of open technologies. We do have some open source software licenses that have been tested. But as far as I know, no open source hardware licenses.
So it's going to be a case of wait and see whether the copyleft, weak or strong, stands up.
Yeah, absolutely. And I think, the legal effect is one thing. The other thing is, you're making a declaration about your intent is X by releasing something under a particular license. And I think they do have a normative effect on the basis that people will by and large, will try to comply with what you actually want. But yeah, it's entirely possible that could potentially be a lawsuit at some point.
Andy, why don't you give the microphone to the gentleman, and then Andrew, if you just let Tim set up, and then you can answer this question.
Thanks, Andrew, and thanks for your work on the CERN license, which I use quite a lot. There's a lot of talk about vaccines and medicines being openly licensed.
Yeah.
Is there anything that they're types of hardware in my mind.
Agreed. Yes.
Are there anything we can learn from that we can apply to, say, medical devices? We're making a lot of open hardware medical devices in disaster zones around the world.
Yes.
But the conversation seems to be very split between vaccines and pharmaceuticals and medical devices.
That's a really good question, and basically because you have another spectrum here, and one of the spectrum is with software, you don't really have to think about the externalities too much. I mean, occasionally you have to think about sort of, cryptography and export regulation and so on. But generally speaking, you get a bunch of source, pop it into a tool chain, something pops out the other end, that'll be subject to your open license, you can do what you want with it. Medical devices, we sort of touched on earlier, or automotive, you have this extra layer of regulation, and you've got to figure out how you can make the regulation work with the openness. When you're talking about vaccines, then you're presumably an even more heavily regulated area. And I mean, in the sense, once you've actually got, I mean, I worked with a client who worked in drug discovery, and some of the molecules that they're working with are extremely simple, and you can sort of basically describe them in a little diagram and a formula, and sort of third of a page of A4 will fully describe what the molecule is, but the effort involved of getting it is where the value comes in. So I don't know sort of enough about sort of microbiology, whether that's necessarily the case with vaccines, but there's going to be an awful lot to actually make any use of this vaccine, you're going to need an awful lot of hinterland that is also going to have to be licensed in some sort of compatible open way. So yeah, great question. Thank you.
Thanks, Andrew. And thanks for all the questions. So yeah, your stuff and then the mic. So next up, Tim and Bruno are going to talk about a path to net zero with monitoring. So appreciate the presentation. Thanks. Go ahead, Tim.
Okay.
Thanks again.
Good morning, everyone. Apologies if I sound a bit croaky. This is my second conference in a week. I was at FOSDEM at the weekend, so I'm starting to flag a little bit now. So I'm Tim Telford, CTO of DevTank Limited. We're a test and measurement company based in the Midlands, and we do open hardware, open software, and open data solutions. And I'm joined here by Bruno.
Yeah, I'm Dr. Bruno Galota. I'm part of the University of Derby. I'm a researcher within sustainable operations, sustainable supply chains, and of course that now I'm working towards the digitalization and the usages within the industry to reduce carbon emissions through the gains on productivity.
Okay, and the talk today is about our journey to net zero and how we start that journey by intelligent monitoring, and in particular open source monitoring solutions, which is the work we've been doing with the University of Derby. So just a quick agenda, talk a bit about the company and other things that we're doing. I'll talk about the Open Smart Monitor brand and the product, university introduction, the motivation behind why we're doing what we're doing, what can we measure with our hardware, and a bit of a live demo, hopefully, and some case studies, and then where next. So who are we? Well, like I said, we're a small business based in the Midlands. We've been doing test and measurement solutions for about 8 years now. I'm ex-Rolls-Royce Aerospace, used to work for some big corporations, and eventually I saw the light and realised that there's a better way of designing products, and we're very much into open source solutions for business, for the business sector. And disruptive technologies where we see ourselves ideally placed. We do IoT, production test, and automation type services and solutions. And we're prolific users of open source tool chains, so we use open source tools to develop open products, which is quite unique in the marketplace. There are other companies doing it, but not that many that I know of, and especially not that many doing hardware and software. So just a quick lineup there of our products. So the one on the left is our Hilltop, which is based around the Raspberry Pi. We're also Raspberry Pi design partners. So that's a modular platform for production test, hardware in the loop applications, and general test and control type applications that you might have in a lab, laboratory, or production environment. We do test modules that plug into that chassis. Open Smart Monitor, which is what I'm here to talk about today, and then we do production test jigs as well. So a large part of our business is helping other companies test their volume products, whether that be open or closed, but all our solutions are open. So the brand that we've been building for the last couple of years is Open Smart Monitor, and the diagram at the bottom there just gives you a quick sort of infographic of how it works. So this particular product uses the LoRaWAN protocol, and we send data wirelessly. It's environmental and energy monitoring data. We send that to a gateway. It can be any kind of LoRaWAN device or public infrastructure gateway that's already available for you to use. And then we use an open stack, so we're using Influx, DB, and Chirp stack. Grafana, you can see there, we're not about reinventing the wheel, we're about taking the best of what's out there already on the marketplace, bringing it all together under one roof and making a solution that people really want. And that's the power of open source. So I'll move on to yourself, Bruno.
Yeah, no, thank you, Tim. So just talking very briefly about the University of Derby and the work that we have been doing in there. Just to explain, of course, that whenever we talk about the university, we're not only talking only about teaching, but also there are some other elements that are very important for the university. So they are aspects related to funding, but also research and innovation, training and development, talent and recruitment, and facilities and networks. And that was pretty much how I found Tim and DevTank overall. So we've been working together for about 4 years now, almost 5, I guess. And I was part of a project called the ERDF Decarbonize Project, which was aimed to reduce the carbon emissions from companies around the East Midlands region. And then we met each other and we saw that there was a potential for some projects together to support local SMEs, which we will detail further on. Just a little bit in the focus of research and innovation, which I think is quite important and quite relevant to the audience of this particular conference here today. The university focus not only on the business improvement, but also in sustainable and clean growth, supply chain improvement, and of course, data science as well. Again, some of those topics are quite relevant to the discussions that we had over the last few days. So just to explain a little bit about the main purpose of the project and the main ideas of the project, of course that, as we know, recession, it comes in waves. As we can see there, this cartoon actually illustrates that, because we do have that small wave that came with COVID-19. Of course, before that, we had a bit of another wave that came after Brexit, also mixing together. And then what we are observing now with also the actual and the current Russian situation, we have seen a big change in a lot of things. So a lot of things have been changing over the last few years. So we know that the prices of electricity, gas, and pretty much everything has just skyrocketed. And we know that things will only get worse. And I'm sorry, because this is the sad part of the presentation, and everyone just gets very demotivated at this time. But what we are here to say is that it's very important that we know what is the problem, but also we know what are some possible solutions. I'm not going to say that they are the actual solutions, because of course with those things, changes in technologies, they might occur and change the status. But of course that we have an idea on what we can do to reduce that. And in order to solve some of those challenges, and more specifically around climate change, we know that the UK has a clear strategy to reduce the carbon emissions and has the targets to reduce it by 2050. But in order to do that, we need to improve efficiency. And I think everything that we're talking about today, we're talking about efficiency gains, because if a company gains some sorts of efficiency, it starts wasting more, it starts wasting energy, wasting heat, and so on. So those are actually very good ways for a company to respond on that. Basically, this is just an overview about the companies here in the UK. And to me, as a researcher, it's very sad, because whenever we see a big change and a big development, especially talking about carbon emissions, we tend to always see larger companies and large corporations talking about that. But what is really sad is that in the UK, the SMEs, they are 99% of the businesses across the country. So for me, it's just a bit illogical that we will achieve net zero if the companies that represent most of the companies, they are not in the same boat. Because the SMEs, they represent about 50% of the business emissions across the country. And if we think about in the European Union, they represent 70% of the industrial pollutants. So, of course, that they are big players, and there needs to change for the SMEs. And again, as I've mentioned before, this is some data from Make UK from September last year. Pretty much at that time, the energy costs were seen as causing one of the catastrophic disruption around businesses, and this data is from the UK, but also some other aspects, for instance, about material costs and also materials availability. It's important to mention that this is from September last year because, as we know, the prices of energy, so not only electricity but also gas, has been changing quite constantly. So if we took a picture of those figures today, this might be a little bit different. So probably the energy cost is going to be a bit more blue than it is. And it's quite worrying, specifically if we think about the SME scenarios. And if we think about the SMEs, they tend to have more problems with this changing situation. So yeah.
Okay. So talk a little about the hardware now, as this is a hardware track. So what can we measure? So with one device, we tried to design something that is a bit of a jack of all, really, and one box, lots of tricks. So it can do electricity and gas via external connectivity to M-Bus or RS485 Modbus type devices. We also have CAN bus on there for tapping into existing systems that you might have in a factory or a building. Water. We can get these flow meters for water and gas that we can tap into and connect to this. Internally, it's got air quality, temp, humidity. Air quality is a really important parameter for many businesses and workplaces. Light levels and sound levels, again, very useful, good for HSE, legislation, that kind of thing. There's a picture there of a typical Modbus meter that you might get in a building, and we can tap into those and daisy chain them together and get lots of data wirelessly to our dashboard, and you can see all that in real time. Now, this is just a quick overview of the hardware. So this board was designed in KiCad, one of the many open source tools that we use. Fantastic package. If any of you used it already, you'll know. So double-sided board, and the brains of this particular device is the STM L4 series microprocessor. Like everyone else, we've had issues getting hold of parts in the last couple of years, and we've had to redesign several times, which has been very painful. Changed a few of the sensors there. So we've got MEMS microphone, particle sensor. You can see there, wireless module is an off-the-shelf rack wireless module that has the LoRaWAN protocol built into its stack. And then we've got external inputs for CT clamps as well, current transducers, so you can clamp around cables and monitor up to one channel of free phase or individual single phase circuits, depending on what you want to monitor. And this is all published under the CERN open hardware license that we use for all of our hardware designs. And there's some references at the end where you can go and have a look. They're on GitHub. Have a look at the designs yourself if you're interested. So live dashboards, what's it all about then? Why are we bothering? Well, the real thing is to get finger on the pulse data and insights into what's going on, right? Get some feedback. You can see the costs. You can see the carbon emissions, how much energy you're using per day, per week, that kind of thing. Business insights. You can set up trips and alarms. So Grafana's fantastic. It's very easy to set up alarms and alerts. So get it to automatically email you if parameter goes outside of a tolerance or spec. And machine utilization and machine efficiency is where we've done a lot of work in smart factory applications. Got some great case studies to present shortly on that. So quick live demo, if it works. I'll just have a little look at our data from our office. We've also got sensors set up here in the building, and we'll be doing a mini report on our findings after this event. So this is just from our office, just to give you a quick overview of typical data. Let me just zoom out. It's very large for some reason. That's time range. So you can go back as far as you like, really. You can go back several days or hours. Let's go back one day. And let's just put let's go 2 days. There we go, that's better. So these are kind of graphs and traces you typically see on one of our dashboards. So in the office back in Derby, we're looking at hot and cold water, energy, current. This is the current on our main incoming feed into the building. Humidity, temperature. We're looking at the loft temperature as well to see how good our insulation is. Obviously, cost is very important for any business. We want to see how much it's costing us to run the premises. Not too bad at the moment, it could be worse. And CO2 emissions, obviously, very important. So just a quick overview there of a typical dashboard. And I don't know, some of you will be familiar with Grafana already. Let's just have a look, see if there's any more. No. Yeah, it's for some reason. Oh, there we go. There we go. There's another view. That's better. So internal temp, loft temp, sound levels, humidity. You know, it's just useful to have this data. And what we did find over Christmas is that we had a water leak. Just saw some pulses all through the night, basically. Very small pulses of water flow and consumption there on the water. And traced it down to one of the toilets in the building was leaking. So little things like that, you know, make a big difference over a year or several years. I'll go back to my slide pack now. Okay. Flick through where we are. Okay. So, some case studies now then. Let's talk about the work we've been doing in the region. So, a big part of what we're doing is to make traditional businesses smarter. The picture there is a textile company in Derby. It's in an old Rolls-Royce factory. And this is typical for the region. You see lots of traditional businesses making products. Some of the machines date back to Victorian days. And I'm not kidding there, they really are very old machines. And they kept them going and maintain these machines for many years. And what we're doing is we're trying to improve efficiency and drive down the running costs of those businesses. We're trying to survey what's going on in the environment, see if there's a better way of controlling those assets and that environment that they're working in, that workplace. And really try and make improvements by looking at the data and getting insights from the data. This is a case study. Bruno, do you want to talk about this one?
Yeah, I can just talk very briefly about this one. So this Superior Wellness was one of the SMEs that we supported as part of the ERDF Decarbonize project. In total, we were able to support, I think, 6 companies. Initially, we were supposed to only be supporting 3, but of course, we were able to find some additional funding to support more companies. As Tim was describing, a lot of the companies pretty much in our region, they are like with very old heritage buildings, which is simply a characteristic about the region, which is fine. Something that I find interesting as a researcher with experience in operations management and sustainable supply chains is the very nature of the businesses and the very nature of the industries that were placed in those buildings. Because if we think back then, more years ago, most of the companies that used to be part in there, they were heavy users of energy and heavy consumers of electricity overall. So the power factor, which is pretty much the voltage that they have, was quite high. However, those businesses, they moved countries because now the UK doesn't have many more of those traditional manufacturing companies. Mainly the picture that we have here in the UK nowadays are more companies that focus either on assembly or distribution. And those activities, they require way less energy than the production. The reason that I'm saying this is that this changes a lot because the work that Tim and the guys, they did with a few companies, one of the main impacts that they had was the identification of the power factor and changing the power factor, which means the voltage that those companies are receiving. And simply by doing that and simply by adjusting that, it already saved the companies a lot of not only money, but also carbon emissions, because in the end, that was the main objective of that. There was actually one company that was able to save about, I think it was about 25 or 30% of their electricity consumption. And again, we're thinking about only one company in the UK, but if we scale up to all the other companies that might be in a similar situation, then we start seeing the impact of this type of project. And again, Superior Wellness was one of those examples because they were a distributor of hot tubs around Chesterfield. And the electricity bills that they were having, they were massive. So of course, some changes were needed, and now they are doing a little bit better.
Yeah. Fundamentally, the infrastructure for that business was set up for a much larger org that's doing heavy manufacturing, and they were no longer using the building for heavy manufacturing, so some big changes they had to make to the building infrastructure. So this one here is a job we did for JCB, who are based just up the road from our property, our business. And they had a paint quality issue. They've got an eco paint line, which is a series of dip tanks in the factory. So you can imagine a big cab from a vehicle that they dip into various stages of different solutions. Ultimately, it gets coated in like a protective paint layer, different colours, you name it. There's preservatives in there. So it's a multi-stage plant, and there's some anodes that are inside the tank. And they were having issues where they were failing. They didn't know what was going on. They could monitor the total current from all the anodes inside the tank, but they couldn't measure the individuals. So we set about sort of doing a bespoke solution for them based on this kind of core technology here, the OSM product. Monitored all the anodes, and on day one, we installed it, turned it on, and sure enough, there's an anode not working, or there's data missing from one of the anodes. So very quickly sort of paid for itself, and demonstrated the need for smart monitoring. So that was quite insightful for them, and we gave them a Grafana dashboard. They could see it all in real time, and they've got TV screens around the factory. They've got the visual factory thing going on, so they can now see when there's a problem very quickly and address it. We've done some other work for JCB as well along the similar lines, but all of that adds to efficiency improvements, cost savings, energy reduction, and energy reduction being a really key point. That directly obviously leads to cost savings anyway. So a bit about a project we launched off with Innovate UK and Pragmatic last year. So I think Rob Taylor mentioned Pragmatic in a slide pack yesterday on Chipflow. They're a great company that does really innovative work on flexible semiconductors, and they're building a state-of-the-art factory in Durham in the north of England. And we were delighted to be awarded a project with them to support on sensorization. So OSM here, this product will be going into the factory, planning to build hundreds of these sensors and monitor all the individual machine tools and various stages of the plant, clean rooms. They're building state-of-the-art clean rooms to do the manufacturing in, and they're very into open source tech. And this is not a small business. They are quite a fast-growing company with lots of seed funding. So that's a good one for us and for the open source community in general. So we're monitoring things like compressed air and vacuum pressure, lots of different types of gases, N2O2, CO2. Their whole ethos is about just good enough manufacturing. So traditional semiconductor fab houses need ultra pure water to do their manufacturing. and they're about trying to tune the water, so they're going to harvest rainwater off the roof, recycle it, purify it, and process it. And so they want to make it just good enough for the fab that they're actually trying to manufacture, which is like a low-cost polymer plastic material, flexible semiconductor material. So very innovative, and it's all about resource efficiency. So great project for OSM and open source tech. And the idea is to roll that out around the world once we've got the recipe right in the UK. So we've got one sensor there right now, and it's become the center of everything, basically. We lashed the sensor up, cable tied it to a pylon. It's still a building site, so you can imagine the builders are in and out all day long. I think they shut the site down once already because they were smashing up concrete and there was dust everywhere, and our alarms went off on the air quality, and they were like, "This is too bad, guys, get off site." And now they've got a temporary clean room set up. They're currently monitoring the ambient environment in the clean room, and it's just simple things like humidity that humidity is critical in a clean room. Obviously, air quality is critical. So the one sensor that we've got there is providing them a lot of useful insights, and actually it went down a few days ago because the gateway basically got unplugged, we lost internet, and with the phone rings, that it's becoming very important for them very quickly that they need real-time monitoring, they need that continuous monitoring and that feedback all the time to make sure the manufacturing is done with the right consistency.
Yeah, and also there are some health and safety aspects involved in that, because depending on the industry sector, they might be more relevant to have some of that.
Yeah. So what next? Well, we've got lots of things in the pipeline. We're working on some edge processing devices, which will be similar size to this, but it'll be Linux-based box with a lot more processing power. This is just a little STM microprocessor, so it can only do so much. So the next product will be an edge processor for things like vibration monitoring and maybe more sort of computational heavy applications like that. Where you've got a lot of data to number crunch, get the results out, and it'll also have power over Ethernet and other communication types. We picked LoRaWAN, for this one, because LoRaWAN's used a lot in commercial and industrial premises, and it's very good long-range penetration. But we don't plan to just support LoRaWAN. So obviously, integrating what we've got into other business systems is quite important. So we're looking at how we do that with ERP and MRP type packages, things like Odoo, another open source package that companies run. Ultimately, we're trying to make manufacturing more sustainable and improve the efficiency of how businesses are operating, and very much focused on smart factories at the moment, but there's farming applications, there's smart cities, there's all sorts of applications that can use open source technology like this. And so it's quite an exciting space to work in. And data-driven business models. So it's all about the data and then what you do with it. So we want to try and get more into the machine learning and the AI side of things, and actually start intelligently looking at that data and seeing what we can extract from it. Automatic report generation, that kind of thing. Which is, it sounds easy, but it's not. Lots of people have tried it, and it's something we're very keen to explore and work on. So just finish off with some useful links there, and then we'll take some questions. So if you want to look at the hardware or the software, the firmware that runs on this, you can go to our GitHub pages. Feel free to contact us, drop me or my colleague Bruno here an email if you want to ask any more questions about what we're doing, what we're up to, or you want to get involved. Happy to take questions now from anyone that might have questions.
Thank you for your presentation, and I love the technology. I'm sure Chion-Yura, who was speaking yesterday, the keynote yesterday, would be interested to see some of the research you presented at the start of the presentation there. In the global open science hardware group that does a lot of monitoring devices, although not quite commercially yet, as you're doing, there's a big debate. Calling it open does it help or hinder sales? Does the customer care whether it's open or not?
Well, it's a really good question, because when we started out on this journey, we were a little bit nervous, if I'm honest. We were worried about scaring customers off by being so transparent, so open. But actually what's happened is the open source sort of profile's been raised over the years, and we've been at this for about 8-9 years now. And all the customers that come to us have really embraced the fact that we are open. They've really bought into that, you know, how transparent we are and how we, of course, it's up to them whether they want to share the data with other orgs or, you know, outside their organization, they want to do other open source projects. They're not all interested in that, of course, because they want to use it for their own commercial gain. But we haven't really had a problem with many roadblocks by being transparent, by being open. So, yeah.
So what's the business model around being open?
Well,
how does it affect your business model?
Yeah, very, very good question. So I think in some respects it's easier with hardware, because we sell tangible products, right? Hardware, someone's got to make it, someone's got to test it, someone's got to CE mark it and EMC test it, and we do all of that like it's any other product. And people want to buy just a product off the shelf. Now, with open hardware, there's lots of products which are just circuit boards. You know, I think Arduino was mentioned earlier. There's the Spark Fun that do loads of dead boards. They're all really cool, really good, useful things, but there's not actually that many companies selling a polished product that you can just buy. And we often say to customers, you know, you can make it yourself. Of course, here's the schematics, here's the source code. Go knock yourself out. Or do you want to buy it from us? You know, and they're like, yeah, we'll buy it from you. We don't want to make it ourselves. Why would we? You know, it's not our core business. Now, you're always going to get copycats. And I remember listening to a talk from, I think it was the CEO of Spark Fun a few years ago. It was a TED talk. And he was saying, well, what you've got to do is just stay ahead of the game. You've got to get innovative and keep getting new products to market. And that's what we're doing all the time. You know, we're always trying to stay ahead, trying to build the brand as well and get people following us in what we're doing, and also build a community. I think the community is the hard part. That we're still working on the community engagement, but that will come, you know. So yeah, we sell the product, the hardware, and then we sell support, consultancy, just like any other business really that's doing this kind of thing.
Just a second. Let Sen get in, and then we'll get you the mic.
Hi there. Yeah, so I had a bit of a technical question. So obviously your sort of main goal is to proliferate, you know, open source hardware, which is commendable. But
sure,
I had sort of a technical question, because you're, I think it's like you're like a Raspberry Pi, like a hardware partner.
That's right.
Something like that. And the Raspberry Pi is proprietary hardware. So I was wondering if there was a technical reason as to why you chose that over a more open source single board computer.
It's a good question. We're not wedded to Raspberry Pi at all, really. When we started out in the early days, Raspberry Pi had a great community around them, like many open source products. It was a very low cost computer board, and we thought, actually, let's piggyback on what the community have already got. And when you look at Raspberry Pi, it's full of open source ecosystems. You know, there's lots of hardware, there's lots of plug-in boards, hats. Just because Raspberry Pi keep the IP on the core, it doesn't mean the rest of it isn't open, or some of the other aspects of it aren't open. So I think, you know, in an ideal world, of course, we'd adopt everything that's open and only open, but you've got to be pragmatic about it. And ultimately, we've got to make money as a company. We've got to put good designs together. And it was the support in the community that sort of led us down the Raspberry Pi route. And actually, they do open source their I/O boards and things now to try and improve adoption and get the community into what they're doing. So I don't really see it as a problem. We have looked at using, and we have in fact used other Linux processor boards, not just Raspberry Pi. But you know, for many people, it's a brand that you can see exactly what they're about. You know, people know of them, and that's partly the reason. Being brutally honest.
What the guy was saying there, you know, about being frightened of companies being frightened of open. They've heard of Raspberry Pi, and that kind of gives them a warmer feeling.
Exactly, yeah. And when you're starting out, people don't know who you are, you know.
Forget the chocolate cake.
Here, and then we'll get the gentleman in the center, please.
Yeah, great. Really interesting stuff. You work a lot with UK manufacturers, which is a sector we don't hear that much about these days. What's your impression of the health and the attitude of that sector? Does it feel like it's growing, shrinking? Is it exciting?
When you say UK, do you mean like factories producing stuff in the UK?
Yeah.
Okay, yeah. So I think it's quite exciting. I think as we walk around and look, and we do lots of site visits, you see all sorts of innovative things going on. And I think it gives me a buzz that there's still a lot in the UK happening, and actually things are coming back to the UK, like semiconductor manufacturing, which we really desperately need. So yeah, I think the future looks very bright for the UK, especially with more open source adoption. Yeah.
Thank you.
And especially today, look at all the sunshine.
Exactly.
So if you wouldn't mind the mic, because then it'll be captured as part of the stream and part of the session.
Is it on?
Yes.
Just to add on to the question earlier about the open source and how the business works with that. The Innovate project that we've become a partner with Pragmatic, we would not have got that work and be on that project unless we were open source. That's been made clear to us by the CEO of the company. So we know we're on that project purely because we're prepared to open the data or our designs. They want to pass the data on to a variety of people, including AI people doing weather predictions. They're manufacturing their own nitrogen on site, so they're becoming a very eco-based system. And we're on there purely because it's open source. That's the, sorry, go on.
I was just going to add to that, because a lot of them have been burnt by vendor lock-in. They're just so tired of being screwed over by being locked in. So you say you're not going to do that, and they're just like, oh, thank God. So it is actually, it helps sales.
Beautiful. All right. One final question the morning session. Otherwise, we'll let you get. All right. So let's thanks Tim and Bruno.
Problem.
Professor Galato. All right. So lunchtime session upstairs as yesterday. I think all vegan as is friendly here in the convention center, and we'll be back here at 1:00 precisely. So appreciate everyone accommodating the 5-minute slips that we did. Yeah.
you. For those who don't know, I'm Lesia. I'm representing the Open Compute Project Foundation, and I'm your co-host for the Open Hardware track. And I'm delighted to present John Laban, who is Director of Open Compute Project Foundation, and who will be talking about the sustainable data centers. Please welcome John.
Thank you. Woo, woo. Well, thank you, everybody, for coming. It basically is a software event, so we're never expecting lots of people in the hardware event. And I do find it really funny that when I talk to all these software people, they've got absolutely no idea what sits below that makes this software work. I just find it really interesting. But the magic of bringing all the free opens together, the open source hardware, the open source software, and the open data, and I'm also a board member, by the way, on Open UK, is to try and integrate, get this depth of integration, because when you deeply integrate all those free opens, magic happens. So this is the whole idea of this event, to try and integrate. But this is the first one we've ever done, so more open source hardware people coming forward in time. How many people are into open source hardware in the room? All right. How many people are software people? Right, okay, that's nice little mix, that's good. Right, well, I've got about 30 minutes. I'll just shift through this, and I'm going to talk about sustainability of data centers. And I'm going to take a broader picture on sustainability of data centers. I'm not just going to be drilling into the technology, I'm going to broaden this out into what I see as sustainability as a definition. So what is the definition of sustainability? Now, these are free models that you might see. And the one I really love is the nested loops on the top right-hand corner. And to put that into context, this is called the embedded economy model. And it's really the new form of economics that's coming forward from the new economists. And it's this concept that we have planet Earth with limited resource. Within that, we have society, and within that, we have our economy embedded. Now, what's interesting, if anyone wants to read the book, this book here is a really good book, Donut Economics by Kate Raworth. Strongly recommend it. But this is the new economics where we're moving. And what's at the core of this is the commons. As you can see here, you've got the commons. Now, this is an open collaborative commons, which is an essential kind of ingredient at the core of this new economic model. So for me, open source and open source tech and the collaborative commons is just a lot more than technology. It has a much broader horizon. Now let's just look at a few things, looking at the broader aspects of sustainability, looking at some of the social issues. This was a documentary that was on Monday night, and it was about how bad data centers are in terms of water and energy. This here is from a few years ago. I did a conference in Dublin, and as you probably all know, do you know this little, see that little symbol there? See that little flag there with a kind of this, looks like a circle that lady and that man are holding? Yeah, got the circle and then there's a crossing. How many people know what that symbol is? Okay, that's great. Extinction Rebellion. And it signifies time's running out. It's basically like a sandglass. Now, what's interesting, they demonstrated at this conference, this data center conference, there was over 1,000 people at the conference. And they very cleverly came in, they sabotaged the fire alarms, and there was a mass evacuation. And so everybody left the building. And I was really pleased they did something. And the reason it's happening in Ireland, these demonstrations, is Ireland is suffering from the impacts of data centers in a big way. Really, it is becoming an issue. And I thought, let me go and talk to these people. So they were all standing outside on the street behind these big railings. So I went out, we were all standing on the grass, And I just went outside and I said, well, tell me about what your issues are. And they told me what their issues were. And then I went back inside after an hour when we all were let back in. And I started walking around to the people on the inside. And I started asking, what was that demonstration about? And they were telling me one view. And I've got this, after 20 minutes talking to these people on the outside, I'm getting a totally different picture. And what I realized is a total disconnect. In the data center industry, it's a very inward-looking kind of picture. It's a groupthink mindset that exists within the industry. And there is very little idea of the impacts externally and what people think about them internally. So this is really fundamental, because what I'm going to basically say is the idea of sustainability to someone inside the data center industry is not that big embedded economy model. It's very much an insular, inward-looking thing. Society don't exist within this. And it's going to be a big surprise to them as these demonstrations develop. Things are going to really hit them hard. So you should be prepared for this external threat. You can't just ignore the environment. You can't just ignore society. So that's the fundamental point I'm trying to make here. So just some of the moratoriums. Now, a moratorium is where data centers are not allowed to be built. There's been politicians have come in, policymakers said, no more data centers. And these are just a few. Singapore, got Frankfurt, Amsterdam, but there's this kind of movement that's occurring. It's the impact of these data centers. John, who's sitting over there, this is John Booth, who's really passionate on the sustainability side. If you want to know about a lot more of this, he's the man to talk to afterwards, and he will tell you so much about all the kind of the deeper political kind of shenanigans that are going on in this sense. But here's a few other things, like water usage. On that BBC documentary, that Panorama documentary, they mention water usage. Just to give you an idea, a kind of a sizable data center will use the equivalent in water every single day. And this is potable water, this is drinkable water. Equivalent to an Olympic-sized swimming pool every single day. And all they're doing is evaporating that water into the atmosphere. Every day, an Olympic-sized swimming pool. Go and have a look at the Google environmental reports. Go and have a look at Microsoft environmental reports. Look at Facebook's environment. Look at their water that they consume in a year. It is absolutely staggering. And what you've got to realize is where some of these data centers are. They're in the Arizona desert. And there's a real big water shortage. And now the policymakers are now coming in and hitting them hard, and they're going to restrict them on their water usage. So here's an example. When there was a hosepipe ban last year in the UK, we have a huge cluster of data centers in Slough. We had citizens were restricted on their water usage, but there was no water usage restrictions on the data centers. And this is what's going to start to cause the kind of the turmoil between the citizens and the industry. Now, you can do things better. Things can be done better. Now, at the moment, if we look at heat reuse from data centers, because these data centers, they generate megawatts of heat, hundreds of megawatts of heat, some of them. Now, this is just to try and get you into the idea of breaking down these silos. And something Eric mentioned yesterday, he's talking about breaking down the silos between the software people and the hardware people. But what I'm saying, you need to break down the silos between utilities. So why are we using gas to warm up water when we've got all this heat from a data center using green electricity, which we can then use to replace burning gas? So this is just a 1-minute video to give you an idea on what combined heat and compute is. And it's a technology that's really starting to fly.
Hello. In this video, I will explain about data center combined heat compute. Today exist 3 server heat transfer options. Conventional solutions are based on air heat transfer with fans. on-chip liquid take out partial heat rejection directly from the processors. And third option is full immersion liquid heat transfer without air. In air heat transfer server, fans heat up the air till 30-40 degrees, and after, air heat exchangers produce liquid with temperature 12-30 degrees, which is not warm enough for users. For that reason, we need heat pumps which rise up the temperature of the liquid till 60-80 degrees and after deliver it to the buildings and residential areas. With liquid on-chip heat transfer in well-managed IT servers, 80% of the heat rejection can be taken out from the chips and the rest 20% by air in conventional mode. The liquid from on-chip solution with temperature 55-65 degrees can be directly used by householders. The liquid immersion solution used the servers without fans, which fully immersed in liquid, and the heat rejection from all components is transferred to users with temperatures 45-60 degrees. In conclusion, I want to deliver the message that the combined heat compute is the way for including data center in circular decarbonized economy.
Now, there's very few data centers doing this, but let's take Ireland. 17% of all electricity generated in Ireland is used on data centers today. And the problem is that the citizens are believing that when there is a kind of an over-demand on their grid, that the data centers won't be turned off. The citizen supplies will be turned off. Now, if Ireland started to use combined heat and compute, instead of using gas to warm up water, they could be using all this heat from these huge data centers in Ireland. Therefore, they can decarbonize on the gas and the electricity for warming up water. So overall, by integrating utilities, you can start to see all these benefits occurring. Now, this takes joined up thinking, and there's an organization called the Sustainable Digital Infrastructure Alliance who are working with OCP, and this guy here, we call him David G because he's a Russian guy living in France, who's a kind of a specialist on this. But again, if you want to know more about this, then I'd recommend you go and talk to John afterwards for the detail, okay? So it can get quite detailed, but this is a trend that's happening. This technology trend is happening really quickly. And just in terms of electricity cost, if you give the heat back to somebody else to use, you can reduce your electricity bills by 40%. And they do this in Sweden, they do it in Stockholm. So the energy company that provides electricity to the data center buys back the heat and then discounts electricity costs by 40%. So it makes sense environmentally and economically, it makes sense. And David G has done all the numbers. This is what's special about this guy. He's worked all the numbers out. So go online, you'll see all these little 1-minute videos he's done, and it's a great education, okay? And there's his, you can link him from his website, I think Impleon it's called. But it's just what we need is education. We need to tell people about this. If you want to know detail, go and talk to John. Now, just another thing is about carbon emissions. Now, we touched on it yesterday, and there was a few events yesterday afternoon in this room. And what I really loved was the passion of the people talking about carbon emissions. And what really I did like was the fact that they were women. The passion on the environmental kind of side of data centers, when the women get involved, they really shout about it and they want to create change. There was also Eric there, who has a female side to him, and he was also going on about the idea of this kind of stupidity on the way we do things. So what does it look like? Now, the greenhouse gas protocol, how many people know this protocol? Right, let me quickly cover it for you. What you've got the Scope 1 emissions, greenhouse gas emissions. They're there if, for example, you run diesel generators on site as backup. So that'd be called Scope 1. Then you've got Scope 2. What Scope 2 emissions are, they're the emissions that would be associated at the power station that generates the electricity for you. So when you consume electricity on the site, you're creating greenhouse gas emissions at the power station. If it's a coal power station, then there's going to be a lot of them. If it's wind farms, there's going to be a lot less. And they're called scope 2. And then you've got scope 3. And this is all the supply chain. This is the embodied carbon in the upstream coming in from the manufacturing, and then the downstream as you take product into the recycling side, the downstream side. Now what's interesting, what it looks like, this profile of mix between scope 1, scope 2 and scope 3, and I'm going to ignore scope 1 because it's such a small part of the system. It looks a little bit like this. So if I had a data center in Sweden where they're using very low carbon intensity electricity, this is going to be your whole life carbon profile for a data center. So the stuff at the top there, scope 1 and 2, it's the froth on the top. And at the moment, the data center industry, if you go into a data center and you talk to people in the data center industry, they keep talking about power usage effectiveness. And all they're talking about is reducing the froth on the top. They're not even measuring the scope 3, the embodied carbon in the servers, in the electronics, in the building. They're not even measuring it. So when I show this to people in the data center industry, it's quite a surprise to them. Now, the amount of froth you get on the top gets smaller and smaller and smaller, the greener and greener the electricity. So if we went to France, where you're from, and they have a big realization on this because for decades and decades and decades they've been using nuclear, which is a very low carbon intense form of electricity. And so if you go to OVH in France, they understand this in detail. They absolutely understand it. They've grasped it. They've been doing it for decades. But we can't quite get our head around it. But the point I'm trying to make is where the emissions are, they're in scope 3. They're in the stuff, the physical stuff. Okay? So, for example, if I went to France and I had an iPhone, and I used this iPhone in France, over the life of using that iPhone, the scope 3 would be about 80%. The scope 2, i.e. the plugging it into the electricity grid, would only be 20%. So for an iPhone being used in France, that's the kind of the impact. It's the stuff that's the issue, the embodied carbon emissions in the product. Okay? And just to give you an idea on why it's so bad for electronics, is because when you go into electronics, you get all these precious metals. And one of the precious metals that's in electronics is gold. And if you measured the embodied carbon in producing 1 kilogram of gold, you have to calculate the amount of CO2 emissions just to produce 1 kilogram of gold, you have to multiply that by 28,000. So for every 1 kilogram of gold that you have in the upstream supply, it's 28,000 kilograms of emissions. And we have lots of this, lots of these precious metals in our IT gear. So it's the IT gear that's the real big kind of issue. Okay? Now, how do we draw down this black stuff? This is the real thing. How do we draw down? We have to dematerialize stuff. So let's give you some examples on how prosumer-driven open source solutions within the OCP Foundation dematerialize the data center and also the electronics. So this is a traditional data center, and in the traditional data center you have the centralized uninterruptible power supplies, the generators, you have all these cooling systems, all these chillers. You have what we call the computer room air conditioning units, then you have the IT racks in the top there. That's a traditional system. Now, what the kind of hyperscalers said was, this is crazy. We don't want to work this way. So all the hyperscalers work the way I'm going to show you. This is going to be transformed. And I'm basically going to dematerialize this data center. So the first thing you do, you take out all the chillers. Now, just to give you an idea on the chillers, if I was running a data center with all these chillers, it might be 30% of the energy might all be just allocated to this cooling side here within the data center. Directly you start to take those out, you start to really reduce that figure. So directly you start turning off chillers and you just use, say, ambient air, you massively reduce the amount of energy you need. You take out centralized UPS, so you dematerialize that. And then effectively, all you have is the IT space up there. And now what you've actually done, you've dematerialized the whole data center because it's a lot smaller. So all the concrete is less concrete. Now let me dematerialize a rack. This is a faulty server rack, and I'm going to dematerialize it. And I'm going to take all these bits out. That was the computer room air conditioning unit. So this is the way an OCP rack works. And compared to a traditional rack, I've taken all this stuff out. In terms of value, CapEx, cost, to buy, it's somewhere between $10,000 to $16,000 dollars per rack on a 40-server rack configuration. Plus you've dematerialized it. You've actually reduced the weight of this rack by about 18 stone. There's a lot of carbon emissions. Yeah? Now start looking at the server, how we dematerialize the server. This is an OCP server. Looks nothing like your conventional enterprise servers. There's no power supplies in it. There's none of this stuff in it. They're power supply units, no power supplies. No power cords like that. No cases. No graphics elements. No front bezels, which are just branding. No rails. Basically, you just take them all out. So this is the dematerialization at the server level, and it's prosumer driven. It's not driven by vendors, it's driven by prosumers. This is another example of dematerialization. This is a data center in Atlanta run by Comcast, and this shows you the before and after from the proprietary on the left, which is 10 racks of gear plus all that cable, to the open cloud-based solution, which is 1 rack. So basically you take out 10 racks and you put in 1 rack. That's dematerialization. Now remember all that black stuff? And I said the carbon emissions associated with the data center are that black stuff, the embodied carbon. Can you see what I've done just by applying prosumer-driven open source technologies? Now, I would argue, why is it not happening? The reason it's not happening is because we don't have enough women in the industry. We have all the technology solutions there, but we don't have enough women. And on the right-hand side here, this is an example. This was a picture of the German Data Center Industry Association with a visit from the Swedish ambassador to Germany, who you can guess she's in the middle. On the left-hand side, we were at COP26, part of Open UK. And this is a group photo of all the heads of state. It's like, fine, where's Wendy? Now, you think, I've always had this instinct that if we don't get women in, we're not going to get these changes. We're not going to get this enthusiasm for this environmental side of the business. And now there's evidence coming forward. There's wonderful papers that you can read now showing what happens when you get women into the management positions in organisations. They impact decarbonisation. Those women there were the new economists. So if I just point out 1 or 2, read all these books if you want to know about the new economic models. All driven by women, not men. This is Donella Meadows. She wrote a book with a team many, many years ago in '72. And if you want to know anything about how to action, the impacts of climate, the way we live, Limits to Growth. Fantastic book. And then watch this. It's a series of lectures about sustainability using systems thinking. And there's one thing that she mentions in this, which is a key ingredient, and it's this. You will never achieve a sustainable system if you haven't got social equity. And in this lecture, she gives an example of why you won't. So social equity is key to the whole of this. And all I say is, I'm introducing you to this wonderful woman. Who knows Vandana Shiva? Who knows her? Go and read her books. Go and read what she says about patents. Go and read what she says about monopoly control. So we need more women in the industry. And luckily, we've got one woman there. We've got a few more women, but we need more women in because they create the change. And there's such good evidence today about the impact when you get women on the boards of businesses. Thank you very much.
You really know how to make women feel special in the data center.
We've also got a woman at the back there as well.
Yes, correct. So, any questions?
That's good. Right.
John, I have for the protesters, I haven't already. For the protesters and those, I think one of the things you were ultimately saying is there's an information disconnect, right? The folks inside the room didn't really know why the protests are upset, and the protesters don't really understand how great everything is that we're doing in the room, right? They don't appreciate necessarily. So is there a way, how do we, in the public, how do we address that kind of?
Well, we need to educate people in both ways. How many people have ever been in a data center? Well, this is unusual. If I was in Civvy Street, so to speak, outside of this area, and I said, what's a data center? They wouldn't even know what it was. And I think what we start to do is create communication, get people into these data centers, and then start conversations. And that's really what we've got to do. And then we'll understand each other's position. But at the moment, you've got group thinking one side, and you've also got it on the other side. But where I sit, I think what we do in the data center industry is abysmal in terms of its environmental impact.
I'm going to have to count that, John, because
Wait, hold on, just use the microphone.
Yeah. So we're currently working with the largest data center construction project in Europe down in Portugal, and sustainability is very much embedded into the heart of their thinking. That may be because we're embodied client side, consulting on the sustainability aspects. That and the Infrastructure Masons Climate Accord, Climate Neutral Data Center Pact, etc. I do think there is a realization that sustainability is now creeping up the agenda, but it's how you deal with your legacy assets that is the main problem. Most new data centers are fairly sustainable. They are looking at ways to do that. Having said that, we've come across our Portuguese client's consultant was very reluctant to get involved in some of the suggestions that we put forward. And I would agree with you. There is a body of evidence, and I think I know what the problem is, right? It's somebody else's problem field, right? A lot of these people that work at senior level within these organisations are nearing retirement, and this is teaching an old dog a very new trick, and they really don't want to get involved. They just want to see out the last couple of years before retirement, doing what they've always done for the last 30 years, and that is the problem. When they're gone...
John's making a really important point there, and how do we change these cultures? We need to shake things up internally, but the evidence now, if you have a look at the sustainability professionals, and my wife is a sustainability professional, and what I find is 80% of these professionals are women in sustainability. They're not men. They're driving the big changes. We need to get them inside the organisations. We've got Mark there. He's dealing with sustainability professionals because we've set up a sustainability working group within the Open Compute Foundation. And the enthusiasts are women. They're the drivers. They're the people pushing it forward. But that is fundamental to it. And just one thing, if I can show you this. This is a book that I recommend you all to read, and it's called The Best of Times, The Worst of Times. And in the end of it, it's a fantastic book about what we should be doing on the climate emergency. And in the end of it, the conclusion is the first element on the conclusion, and I'll kind of read it to you, and it says, we need the continual enfranchisement of women globally. It's women are core to this transformation. So that's my message. Thank you for listeing.
One more question.
I have two questions, if you don't mind. My name is Mark Ballard. I'm a freelance journalist. I was wondering, you were saying about you seem to be implying that you believed it was a problem that in Ireland, people, or in the UK was it, people had a hosepipe ban, but data centres weren't switched off. I wonder if you would say the same thing about the steel industry and the chemicals industry and the transport industry. the farming industry. I mean, which are you saying that the data center industry is just one industry that needs to be switched off when there's a drought, or is it that people are so precious and fragile that they can't do without a hose pipe for the summer when there's a ban?
No, what I'm saying, good point about there's other. I'm talking about the data center industry, but remember,
Yes.
in my model that I showed you, I was talking about a planetary-wide system. But let's just try and focus it on the data center industry. What really makes me angry is this: the technologies that have been used for over 10 years now in some of the data centers that you use for your applications, they use much less resources. They're not dependent on water. You can design data centers without any water usage. And what annoys me is that there's a large... Sorry?
They use more energy when they use less water.
No.
Not necessarily.
No, they don't.
Okay,
No.
okay.
And see, and this is, the technologies are all there. The solutions are all there. All we need to do is change and act and adopt them. For example, if you want to dematerialize, because were you here when I showed the kind of scope 3, that most of the black stuff in the emissions? If you start using second user servers or extend the life of a server, you massively reduce. It's not an energy problem, really, when you look at emissions. It's a stuff problem. So just by extending the life of servers, so if you go to France, which I mentioned, OVH, they get up to 13 years out of their servers.
So do you believe that that data centers should be switched off so people can keep their hoses going?
No. What I'm saying is there's an issue with the society who are seeing that the data centers are taking a priority, and that's why you're getting all these demonstrations in Ireland, and you'll start to see them elsewhere. Because there's a disconnect in the data center industry that people don't imply and act on the broader society issues on the sustainability agenda.
Okay. May I ask you one more question?
No, that would be 3. We really are. We're over on this session. Please, we can save them to the...
Yeah. Take it offline.
Yes, please connect him with John offline. Thank you so much, John.
Well, I hope you can. Thank you very much.
So I would like to invite our next speaker, who is Chris Lloyd-Jones, the head of Open Technologies. And we'll be talking about the Open UK's patchwork killed data centers. Please.
Okay, yeah, let me... no, let's not use John.
Okay. She's not giving me the USB-C thing. She just gave me the...
I got it.
Okay, cool.
If you do, I just want to introduce yourselves and,
Yeah, sure.
and start while I figure this out.
Hi there. My name is Chris Lloyd-Jones. I'm head of Open Technologies at Avanade. I'm also on the steering committee of the Green Software Foundation. I'm here with London Horizon from the Open Charge Alliance. And we're going to talk to you about the blueprints that Open UK have been producing. So that's previously the patchwork kilt blueprint for open data centers, circular and renewable data centers. And then the newest blueprint that we're about to launch following State of OpenCon, which is the EV charging blueprint. So I'm going to set some context on what a blueprint is and why we make them. And then Lonneke and I are going to talk a little bit more about the work of the Open Charge Alliance, the open or the charge point protocol that the Open Charge Alliance has been producing, and why standards are important for this particular area.
There's no file on here?
There should be a PDF.
No, but there's nothing on the USB.
We may or may not have a copy of the blueprint to show. We'll see, but if not, we'll continue.
Is it on the interwebs?
Yes.
It's nothing to do with the video. There's no presentation.
Just open it on the left.
I see.
That's what I'm saying. But I can just download it from my email if you want. I can open it.
Oh, this is your machine.
No, it's
It's still John.
Sorry, minor issue there.
Sorry about this.
That's my fault.
Is it on the web? You can also...
It is. I can send you a link. It's okay if not. We'll just talk through it. We'll attach the slides to the C event afterwards, so you can download the PDF just in the interest of time. But a blueprint is, well, it's a very common term, but in Open UK, a blueprint is something which we've developed to try and analyze a particular area, particularly relating to sustainability, to identify key components of a particular industry, segment, or sector. So for the patchwork kilt, that was to identify all the components and pieces that form part of a data center, like the Open Compute project. I will say I was not part of that blueprint, so I'm not as familiar. The newest blueprint was kicked off in July of last year, and working with BEIS, the newly defunct government ministry as of yesterday, the Scottish Futures Trust, the Welsh Assembly Government, the Northern Irish Executive, Intel, Microsoft, and tons of other partners, we've identified what people think the key themes are in the space of EV charging. So that is, how do we focus on circularity and sustainability? How do we engage local communities? How do we collaborate across these sectors to improve energy infrastructure, to support charge point operators and connectivity, to make sure that EV charging supports the local community, to make sure that regulatory and planning policy takes into account rural density, cities, highways, how people might want to charge their vehicles, and finally, end user services. For the current battery technology, which takes some time, how do we make sure the services are there to keep people engaged and happy and able to travel from point to point? So Lonica, if you'd like to come up and talk a little bit about the Open Charge Alliance and the Charge Point Protocol, and then we'll talk a little bit more about the blueprints and what we've been working on.
Yeah, sure. So, hello everybody. My name is Lonneke Driesen, and I work for a non-profit organization based in the Netherlands called the Open Charge Alliance. So in 2009, one of the founding members of the Open Charge Alliance decided to install charging stations in the Netherlands to kickstart the market. Back in those days, there were hardly any vehicles available, and there were certainly no charging stations. And to solve this chicken and egg problem, this company, ELAT, just installed 3,000 charging stations all across the Netherlands. And of course, from day one, they had this mindset that they wanted to have a multiple vendor network. And they wanted to use a standard. And they asked the charging station vendors back then if they had a sort of standard protocol to communicate with the backend system. And there was nothing. So then ELAT said, well, if there's nothing, we'll just start writing something ourselves. And since the main purpose of this market is that it should grow, why not give it away as open source? So that's when the protocol OCPP started, an open source standard, which very simply, it's not rocket science, it just describes the information exchange to a charging station. And since it was so early days, there was not a lot around. Everybody started using it, and at a certain time, it became such a broadly adopted protocol that the company ELAT decided to hand it over to a non-profit organization called the Open Charge Alliance. And this was in 2014. Since then, the whole EV charging market has grown significantly. The EV market has grown, and now with the pledges from European governments, American governments, Korean governments, that actually encourage the transition to zero-emission transportation, the adoption of our open source standard has also grown. So currently, we are used by a lot of organizations in a lot of different countries. The standard itself is open source in the sense that you can just use it, download it for free. There's no IP in it, of course, no licensing barriers or whatsoever. Some companies actually develop open source code for a charging station. So if you're building a station, you can just use their open source code. But there are also a lot of companies who have their own software and have a different business model. But the standard itself is all open source code, and we're really happy with the decision that was made, I think 13 years ago, to go open source from day one.
Yeah, and Lonneke came on board very early on in this initiative. And one of the reasons why Lonneke's on board and why other organizations are starting to work with us is because the aim of a blueprint is to analyze a particular sector. And I mentioned that already, but the reason why we do that is we often find there are gaps in the sector. So there are services which aren't being addressed or metrics which aren't being considered. So all of our stakeholders took part in a series of workshops from July through to November, where we identified primary stakeholders, secondary stakeholders, and we started to map out all of the interactions between various bodies in this industry. For example, the EV charging operators, they provide designs for open source hardware plans. We find here they share status updates with local planning sectors in some areas. We've got organizations like the Open Charge Alliance who provide the standards for these charge points to share data with the energy grid, with the vehicle, with other vendors. But once you identify all the various stakeholders, once you start to identify the various use cases, and I mentioned earlier on the key themes of circularity, local economy, and collaboration, you can start to identify key themes, key reasons to actually collaborate around open source standards and initiatives. And then we can identify where the open source community is maybe underserved, where there are gaps in the infrastructure, where there is software or data which is missing, which then can lead us to engage with other bodies to try and resolve problems. So Lonka and I were chatting yesterday, and we were chatting about the adoption of electric vehicle charging in the United States, and you were telling me about how standards are or are not supporting the adoption of electric vehicle charging in the United States versus in Europe. So while I move on to the key themes, I don't know if you want to discuss that a little bit more and describe the problems there.
Yeah, so this is something that so I never realized, and I'm encountering it now, and I've learned that it is an issue for all different areas in open source. Is initially the industry, consumers, certain companies were promoting EV charging or electric vehicle adoption in general. And what you see is more and more governments are mandating transition to zero-emission vehicles as of 2035 or whatever. 2030 sort of depends on which country around the planet. And in order to push that a bit further, governments are also starting to put in place legislation, regulation, and also mandating standards. At the moment, the standards that they mandate are not a mandate in general, but just a prerequisite to get government funding. So you don't have to use a standard network infrastructure, but if you want to get government funding, then you have to implement standards. And what we see that, for instance, the Korean government has mandated this, our open standard OCPP for government funding. OCPP is not a formal standard. It's not set by ISO or IEC or IEEE. We're just one non-profit organization, but the Korean government is fine with that, and they are mandating OCPP. Same goes for the American government, the California government, but also the US federal government. If you want to be eligible for government funding, and there is a lot of government funding becoming available in the United States this year and in the years to come. Also, OCPP is a requirement, even though OCPP is not a formal standard. But the situation is very different in Europe. The European Commission, as we are being told, and we're still looking for the exact document and place where it is written explicitly, states that the only standard the European government can mandate are ISO standard or IEC standards. And we keep asking why, and the answer is, well, because that's what we always do. And therefore, they will not consider OCPP as a standard in Europe unless we hand over our standards to either ISO or IEC.
So to reframe that another way, the US has a very mature charging infrastructure, or it's maturing quite rapidly. And when we look across the key themes that we identified from our research, energy infrastructure, regulatory and planning, vehicle infrastructure, end user services, charging operation connectivity, and then community engagement, that leads us to be able to identify a set of high-level components which any mature market, we think, based on our research, needs for EV charging to actually roll out at scale, at pace, without prejudicing any one group or community. Now, the OSPP would fit into the charging operators category and the regulatory and planning category as it's a standard. So then we can identify gap analysis where by geography, some of these components might be missing or might not be fully realized, and therefore an open source community can step in. So at the end of the state of OpenCon, we'll be releasing this high-level document, the blueprint which comes after it, because this was the initial planning, and the data sets to actually show where, based upon this research, we've identified regions that might have particular gaps. For example, Scottish Futures Trust is the body taking over EV charging points in Scotland. And some of the concerns that they've mentioned is that Scotland effectively set up EV charging points that were subsidized and run by the state government. Now, when the market needs to expand, what has happened is that the government, through over-focusing on regulatory and planning, has somewhat distorted the market. And that means that other players, other charge point operators and connectivity providers don't want to step in. So again, the aim of this blueprint is to identify various different options, various different components that any mature geography needs to have for electric vehicle charging to be adopted. And this now, I think, leads me on to the standards conversations. You're mentioning about ISO standards, EC standards. Now, there aren't many standards in the world which are both open source and supported by standards organizations. And Lonica, I know you were mentioning there have been some issues with yourself. Could you just explain a little bit some of the problems that ELAD's had in engaging as an energy provider and as the Open Charge Alliance with bodies like the European Commission and others?
Yeah, so the way OCPP was developed, not made intentionally, but sort of organically, was in 2009. We wrote the first version of the protocol, and it got implemented, it got tested, and over the years we learned and improved and added more functionality and features to the protocol. So sort of in an agile way, say every 3 years there was an updated version. And every version that was available was not perfect, and there were issues in it, and they were incomplete. But the next version, step by step, added more features. And this is, of course, very logical, because back in 2009, we could never have imagined how the market would develop. So in a very rapidly and diversely developing market, having such an agile way of developing a standard makes perfect sense. At ISO and IEC, though, we have been told extensively that this is not the way you develop a standard. The way you develop a standard is first you think of use cases. So what is the use case that you're trying to serve? And then afterwards you define an information model. So what does a charging station look like? And once you know what a charging station looks like, which component, then you define messages. And you don't define messages just like that. You define them in alignment with already existing standards that connect to this standard. So those three components we think are not the way we approach things, and not the best way to approach things. So first of all, think of use cases. In a very mature market, you know what you want to use it for. But in EV charging, over the past decade, you didn't really know what use cases, what market developments, what business cases would apply. So it's a sort of an impossibility to, say in 2015, think out all the use cases for the next decade. The second part, what does a charging station look like? So what are the information components? You don't know. Will it have one socket, two cables? Will it have a cloud connection? Will it have, you know, it's too early in the market to define a fixed information model for a charging station. And the last one, the sequence of thinking it out and aligning it with existing standards. This makes the whole development of a standard very political, because there are already standards in place and business interests in place and IP in place. And if it doesn't match perfectly, they will start arguing for their case and not thinking greenfield, what is it that the industry actually needs. Yeah. So there's sort of a fundamental discussion we keep having with ISO and IEC that the way we do things is wrong. So we thought, well, okay, fine. So we just continue with our open source standard, and it's very successful, we might add. And so that's good enough for us. So we're happy never to become an ISO or an IEC standard. So that's not our aim, so we're fine.
So Lonica was describing a number of the problems there with one of these particular components, with how we make sure that the standard itself is open sourced, adopted then by more formal standard agencies to allow a particular geography like the European Union, European Commission to mandate this across Europe. I talked earlier about the United States and about how they have adopted OCPP and how they are already using that standard across the United States. In a session this morning, we had Leanne Kemp from Australia talking about similar initiatives there. But the idea here is that these blueprints we're releasing provide a menu of components which we need, which I've already said, in order for a particular sector to be improved, so we can identify where there might be gaps in some geographies but not others. And I'm mentioning this to all of you because the data sets behind this are going to be released, and what we're looking for is for the open source community to review what we've made, to identify where there might be gaps, and work with us as we now move on from the theoretical data analysis, the generation of a high-level blueprint, to identify where there might be projects which could sit with existing open source communities like LF Energy, like the Green Software Foundation, like automotive grade Linux, to actually then build out these gaps and share the knowledge. So that was all I had to say on the blueprint. Before we open up for any questions around what a blueprint is, why we're releasing it, or how you might get involved, are there any final points or takeaways you want to add about OCPP?
Just a takeaway, I think we're really happy that we opted for the open source approach back in 2009. It's been really successful, and yeah, it's already helped this market develop a lot. Not just that, almost every charging station is running on Linux, just very simply. I think a lot of people don't really realize or consider that they're using open source and what it is able to do for them. So it was before I joined this development, but I'm really happy that the people who started it back in 2009 said, let's go open source from day one.
So with that, I'll close for questions. If there are any questions about open EV charging, the standard, or how you might get involved, please feel free. Thank you.
Thank you so much. So do we have questions?
I have a question. Who of you already drives an EV? Oh, good. And?
Don't have an issue. So I use the Tesla supercharging network and charge at home mostly. So although I'm aware of the issues around incompatibility of the payment process between charging providers in the UK, I'm not suffering the issues because I've purchased a vehicle that's got more than 300 miles, and because of the, well, we personally travel, that is more than enough so that we don't have to use charging networks.
So this is a real good example. So you have, of course, Tesla. We all love Tesla because basically if it weren't for Tesla, none of this movement would have really taken off. It's just that Tesla is showing that it can be done. It's a great car, and it can also be very profitable. Tesla is a very highly valued company. The thing is that with this sort of Tesla, everything's proprietary. It's their own charging network. It's everything, their own plug. It's all one brand, which is great. If you look more into the future and more diversity and different brands, then of course you need to go to interoperability. And there, of course, the Tesla approach, well, it's a very good approach, but it's the scalability of not everybody can own and drive a Tesla or charge it.
Exactly. When we were talking about this yesterday, one of the key problems we had is that Tesla, the Polestars, the BMWs and the Porsches and the other vehicles of the world, yes, they may have either access to proprietary networks like Tesla or be able to support a much greater charging range. But how does that ensure the majority of society at an affordable price point can move to these vehicles? So part of this is to ensure that wherever you are, if you live in a rural area outside a big city, if you're living above the breadline, you might need to be buying a vehicle which has been refurbished or renewed, that you aren't cut out by virtue of your job, your location, or your access to funds for these vehicles. Tesla's a great network, but we're also trying to make sure that everyone else is involved.
Yeah, it's like a great Kickstarter, but yeah, the whole planet cannot depend on the Tesla charging network.
One other point, I know that in the Netherlands, Tesla was able to then, allow access to other vehicles and other groups to use their charging network, which I believe has happened in the UK in some small way. It's really interesting the way you've spoken about it. After your Glasgow speech, I then contacted my MP about this issue in the UK, and so this is a few years ago now.
2 years.
And they were saying, and he got information back from the minister in charge in the UK government to say, yeah, we're dealing with this, and we're going to fix it. What's happened? I'm interested to know what's happened in the UK.
So again, BEIS, as of yesterday, now defunct, and we haven't yet reconvened with their contacts to find out what that will mean for this project. But the Cabinet Office, the Geographical Information, I can't remember what the S stands for, the GIS team within the Cabinet Office and the Equipment Across Scotland and the like are working on this project. They're actually providing a large amount of the data for where EV charging points are sited, for whether they are in rural or non-rural areas, and also they're engaged in setting standards for end consumers. based upon some of the work in the blueprint, for example, mandating that chargers must have a certain amount of uptime. They're looking for around 95, 96, which I think is slightly lower than in the Netherlands. And they're also looking at ensuring that these EV chargers take card payments. Because to date, if you look at petrol pumps, there is very strict regulation on pricing, how you show the price, how you charge, the fact that petrol pumps need to be maintained. None of that consumer protection exists for consumer regulation, so this blueprint is helping to address some of those issues through engagement with these bodies as well.
Great. Thank you very much.
Yep.
I think we had another question over there.
Yep, got a couple of... Yeah.
Wait, just like, wait for the mic. Yeah. Can you hear me? Yeah.
Okay.
So sorry, mine was just an intervention because it wasn't necessarily about network of charging points in the city, but especially at home as well. The fact that the providers are quite behind when you think that they're probably using them for themselves and they're probably putting in features that are quite basic. And I'm quite surprised to see that for something that seems to be doing a function that's so basic, the provider I'm using, for example, actually doesn't go far at all. So I can see where open source really could help bring basic functionalities to the homes. But yeah, so I withdrew my question because this is about the home rather than.
Yeah, but I think basically EV chargers in my industry it's very important. But basically, and I don't like it if I say it, but basically just sort of a glorified plug, right? Yeah, there's nothing more. Yeah, and there's a display. And sometimes you can use the RFID card of your mobile phone to pay. It's like that's all. And it sends back information about when you started charging and when to stop. So it's really simple. So I think all these issues that we're facing have nothing to do with technology or the state of technology as of today. It's just...
Because the standard does allow for some of the things that you're describing as well. And part of the discussion we've actually had with some of the energy companies that are forming part of this as well that don't have their permission to mention at the moment. They are also talking about how they might use electric vehicle batteries to help manage the grid, to make them smarter so they can support energy grids in the local area, to store energy from renewable generation on the tops of houses, from wind and the like, and then also to generally reduce e-waste and identify where local chargers might be able to be shared in the neighbourhood as well.
Yeah.
So,
thank you.
Any other questions? No. That said, I'll be around on booth on floor 1 if anyone's got any other questions, and the Open Charge Alliance are on floor 4 if you'd like to actually see the standard or dive into it in more detail. Thank you very much.
Thank you. Thank you.
Yes, the next session here is at 2:20, so there'll be a panel session, so we have a short On the last day. Hopefully we can keep it as lively as we've been. So I'll leave it to Aaron to introduce his illustrious panel.
Brilliant. So my name is Aaron Boove. I run a consultancy called Cloud Sustainably. And I guess I started that a couple of years ago after I was the head of cloud at the UK Home Office. And it's kind of been a journey, and why I wanted to bring this panel together is because I'm starting to realize there's so much more we need to talk about when it comes to sustainability. One of the things is just culture change, there's supply change, there's the real world impact, and you know, what I also did was start a podcast, and I've been able to speak to many of these people on my podcast and interact with people, and more, I'm just thinking, okay, how can we continue this conversation? So I guess I will start. I've done my introduction. Let's do the others, and then we can kick into it. So,
I'm John Booth, Managing Director of two companies, actually, Carbon Free IT Limited, and I'm also the Technical Director of the Data Center Academy. And we're very much on the same page as Erin when it comes to data centers and sustainability. And we provide consultancy and training for that in the near future, we hope, at our site in Rugby, which is actually on a real data center. So it's as close to a real data center as you can possibly get, because we'll be emulating software in there and giving the delegates a real data center experience.
My name is Anne Curry. I've been in the tech industry for nearly 30 years now as an engineer and as a startup founder. And I've been working for a couple of years on writing about how to be greener, how to develop more sustainably, how to host more sustainably. And latterly, I have also been a science fiction writer, cli-fi, sci-fi, and book 8 will be coming soon. But there you go.
Hello, I'm Simon Wardley. First of all, I love your sci-fi stuff, by the way. So I used to work in the environmental field back in the 1990s, when we could have actually done something. I was involved in cloud between 2006 and 2012. I sort of retired from cloud back then. I do something called mapping, which is used all over in lots of different interesting places. And I have a particular focus at the moment on supply chain. So I think that's why Aaron has dragged me along here today. So absolute delight and thank you.
Well, thank you so much for everyone for joining us. And to continue what I was saying earlier in terms of, you know, what do we actually need to do to solve this problem? We need to accelerate it further. We need more people to start caring about climate change and realizing it's a problem. So many of us in tech look at new technology as something just to consume or use or play with. You know, we're seeing AI and ChatGPT and all these other things. I think, you know, Microsoft announced today that AI ChatGPT is going to be integrated directly into Bing. So if you think previously there was a carbon cost of a search online, now there's going to be a carbon cost of a search and a machine learning algorithm being run online, and that's just increasing our emissions. And you know, for this panel, and I'll start with Anne's side really, because we need to think more about, is it ethical? And one of the things I really loved about Anne's books, I came across them after we spoke on the podcast, and I was like, oh, I should have read these beforehand, maybe I will. And then I read 2 of them, and then I read 5 of them in 24 hours. And I was like, hey, Anne, I really like your books. And Anne said Amazon actually sent her a direct email, because that's where they are. And they're like, oh, you've got a new record. Someone's just read 5 books in 24 hours. And yeah, I think one of the kind of really interesting things I was impacted by was, you know, is it sustainable if it can't scale? And
yeah, it's, well, yes, it's certainly, scalability is completely, it's both the potential savior and the destroyer of the planet, in that if it's unsustainable and you attempt to scale it, just burn up huge amounts, it's hugely destructive. But if something is massively scalable, it can also, it's worth investing in making it very much more efficient. So, for example, the cloud is much more efficient, generally, vastly more efficient than on-prem data centers in terms of amount of per job done, per unit of work done, because it really, they're intended to scale, they're planned to scale, and it costs them a huge amount of money if they are inefficient when it comes to either hardware use or energy use. So the cloud, yeah. Scale has good sides and bad sides, as with anything. Scale depends how you use it, doesn't it, really?
Well, that's it, isn't it? It's about, like, when we think about sustainability, it's more than just carbon. There's so many other elements that come into whether it's good for the world. Is it giving us more access to food? Is it helping us with water? Like, what's the environmental impact elsewhere, such as chemical runoff? And that's the sort of thing which I really want to bring to this course is, you know, what are those other impacts and how do we understand the landscape we operate in? So Simon obviously mentioned Wardley mapping. Maybe touch on some of the points we have been researching.
Gosh, you've actually thrown a whole sort of spanner in there. One thing we've got to do is break down the concept of sustainability. But before we get there, I just want to quickly talk about energy. How many of you are familiar with my form of mapping at all? Anybody? Right, super. So for those not familiar, if there's supply and demand competition, any form of competition, whether it's conflict, collaboration, cooperation, things will tend to evolve. They'll diffuse through multiple waves, but they'll also evolve. And they'll go from the genesis of the novel and new, then you'll get custom-built examples, products, and eventually commodity and utility services. So if you think about radio, you'll get the first ever radio, crystal-built radio sets, then my radio is better than yours as we get products. And then we'll forget about radio and we'll just talk about what's on the radio. We'll have the radio times. It'll become more of a commodity. Now, one of the things that happens is as things evolve, they enable us to build higher order systems, what we call the adjacent unexplored. So when compute became more of a utility, suddenly we could do all these new wonderful things. So we could do much more video streaming. We get companies like Netflix. We eventually could do things like large language models. And eventually those become a commodity and enable new higher order systems. So what's going on in the system is we're ever moving towards higher, more ordered systems, and that requires energy, always energy. So the first thing to bear in mind is that whatever we do, people talk about we need to be more efficient. For society to progress, you're going to need more energy. Ultimately, it boils down to the mechanism by which you generate energy. There's only so far you can get with efficiency. Eventually you'll do more stuff, and that's Jevons paradox. Right, so that's the first problem. Lots of people like to think we can make ourselves more efficient out of this. Eventually time will overrun us. The second problem is, what do we mean by sustainability? So there's two aspects. There's the impact, as in, when I take this activity, how much does it impact others? Maybe because it's rivalrous, only certain people can do this. How much does it impact the environment we operate in? And the second aspect of sustainability is how resilient this thing is. So can we be excluded? Is there some sort of constraint within it? Is there security weaknesses within it? So those both are important aspects to the sustainability of something. Now, if I look at something like the retail industry, as I mentioned this, I was on a retail site yesterday looking at impact, and it's wonderful. They had this picture of a hoodie, because I was looking at buying my wee lad a hoodie, and it said 5.86 kilograms of CO2. And I thought, wow, what a very accurate figure for the impact. Isn't that great? So then I looked at a pair of socks, and I thought, what's the CO2 for that? And it said 5.86 kilograms of CO2 for a pair of socks. And then, okay, and there was a duffel bag, and that's 5.86 kilograms of CO2. That's right, every single product in this retail site was 5.86 kilograms, even though they specified it's to the product. So why? How is this going on? Well, it's fairly simple. There's a long, complex supply chain of they get their stuff from various API vendors providing data against products, and they get their stuff from database vendors, and they get their stuff from consultants. So there's a long chain of people working on averages, so you end up with this ridiculous average figure at the end because nobody understands the actual supply chain by which things are constructed. And that is one of the biggest problems that we have from a point of view of sustainability. But it's also the biggest problem we have from the point of view of resilience. So, for example, who knows who Leone is? Anybody? Probably not. They make cable, basically cable harnesses used in automotives. They've got a problem because of the Ukraine-Russian conflict. Their factories are closed down. Because of that, they can't provide cable harnesses to automotive companies who are suffering from supply chain issues with silicon. So they can't manufacture as many cars. So we're not getting as many dashboards, which means we need less leather, which means we get less gelatin, which means you get less gummy bears. So we have these wonderfully long, complex relationships where things over here are impacting things over here. And we see this in the world of IT, whether we're talking about supply chain attacks, solar winds in terms of the digital software, and it's good to see Biden doing that executive order saying at least have bill of materials. It's not far, but it's at least a starting point. We also get both these impacts in the physical world as well. So when it comes to sustainability, you've got to think about the impact and the resilience of what you've got. And in both cases, unfortunately, we have atrocious levels of supply chain awareness, which is causing the weaknesses that we're seeing in the system today.
Yeah, I mean, those weaknesses and some of the stuff that, you know, Simon's obviously very familiar with. One of the things he shared with me is antimony is one of the things that is basically manufactured by Russia, or that's where it's mined. That's
China and Russia.
In China and Russia. And, you know, as we enter into the war in Ukraine, and antimony goes into armor-piercing bullets.
Yeah.
And that's the sort of thing is like, you know, sustainability in terms of those impacts. And it's like, okay, is it sustainable to have a year's-end war with the aggressors who control your supply to your weapons or whatever else? And that's the sort of thing where it's like all of these second-order, third-order sort of relationships exist in so many different things, but they definitely exist in cloud. And the reason why I kind of obviously asked John to join is we talked about energy, but there's other elements of what goes into a data center, and you're probably the expert to go through that.
Yeah, so obviously the first is location. Where do you put your data center? And that needs to have three elements. It needs to have energy, or access to energy. It needs to have comms, access to fiber cables, and it needs to have people, right? And I think there's a big problem at the moment with people going to the Nordics. Right? Mm-hmm. So we've heard all these wonderful stories. I mean, Panorama show that was on Monday, I actually went to a data center in Norway, in Stavanger, in a former NATO base. Now, that is 100 kilometers from Stavanger, right? And it's not an easy place to get to. If it's not an easy place to get to, it's not an easy place to staff. And staff are key to the functional operation of a data center. You can do robotics as much as you like, but you know, at the end of the day, there needs to be somebody with boots on the ground actually mooching around this data center. So those three elements, first of all. And that data center was very lucky because they used a former NATO missile silo, right? So the infrastructure was already done. If you wanted to build a brand new data center, you're looking at vast amounts of steel for the superstructure. You're looking at loads of concrete for the base element. And then the panels, which are usually composite panels. So there are multiple composites of materials, which are very difficult to shred and reuse. And that's just the building itself. Then you think about all of the electrical infrastructure, right? So you've got your switchgear, you've got cables, you've got all sorts of wonderful stuff in the low voltage and medium voltage chain to get the power to the actual servers itself. Then you have the cooling infrastructure, chillers, ducting, piping. Then, maybe your cooling solution might leak. So we better put a leak detection system in it. And they generate quite a lot of heat, so we need to put some fire detection and some suppression equipment in. So you're looking at very early smoke detection apparatus and fire suppression equipment, bottles of whatever fire suppressant you wish to use. You don't want to use water, because obviously that will damage the electronics. I personally feel that any form of suppression is going to damage the electronics, so it doesn't really matter which one you use. But hey, and it was interesting, I was looking at a blog yesterday, and to my mind, the data center industry has stagnated, right, in terms of its design and operations, probably since 1977. So I went to visit an IBM data center near where I live that was built in 1977 and had a cooling tower, right? Now these are pitched as being relatively new, right? But they were there in 1977. I also looked at a brand new data center that was being built down at Farnborough about 2 years ago, and I have seen other new ones since. You can walk down the same corridor and you wouldn't know that you'd moved forward 50 years in terms of the design architecture. We are late to the party in terms of sustainability. Right? But this is very much, I feel, somebody else's problem, right? Most of the senior people that are in charge of the design and operation of data centers are reaching a certain age. I'll say that they're 58 plus 1. until 65. And all they're looking at is, you know what, I'm an old dog. I don't want to learn a new trick about sustainable data centers. What I want to do is just to see out my last remaining years and then retire and go onto the veranda smoking a pipe, drinking red wine. So they're leaving the problem to the young upcoming ones. But invariably in the data center industry, I've seen it myself, they have a standard design. And they'll get a client inquiry maybe 10 years later, and they'll whip that design out, put it down, scrub out the name of the previous client, put the new client's name in, and present that and say £200,000, please. Right? And this blog that I was reading yesterday was saying, you know, they are writing basis of design documents for data centers because most data center people who are seeking to procure them are technically aware. So they're writing specification documents, which leaves nothing for the designer, no maneuver, right? No space for innovation, no space for looking to the future, no space about thinking sustainable. So the design stagnates.
Can I ask you, are you not calling the death of the data center industry there from stagnation, given the fact, unless you are a massive scale player, so if you're just say, a mum and pop investment bank or some, you know, corner shop, supermarket or something like that, you know, you're a Sainsbury's or a Tesco's or somebody, you shouldn't have a data center. I mean, it doesn't make sense, does it? It only really makes sense for the super hyperscalers because they'll understand the supply chain. They'll understand, they have a chance of doing this. They have a chance of providing sustainability. Are you not just calling death on the industry?
I'm not calling
You're efficient, even if you don't like it.
So Simon, I'm not calling the death of the industry. What I am saying is, you know, where did the UK kind of standard data center philosophy come from? And it came largely from the 1980s when the American banks moved into the city, and there was no data center standards, right? And there was a fear of all of the risk profile that they have in the US because of the way that the US operates was brought over to the UK, and these risks don't exist in the UK at all, right? And yet we've designed our data centers for these risks from the US. Right? And this is in terms of electrical infrastructure. Right? So in the US, the electrical grid in certain states and cities is very flaky because there is no national grid. Right? In the UK, we have a national grid. If one power station goes offline, you're not going to see any impact because another one will come up, or there'll be a limited outage. But in the US, they assume that their power station is going to be offline for weeks. So they build this island mentality. And as John said in his open hardware discussion earlier, you've got backup generators and UPSs and all this sort of stuff for a risk that largely doesn't exist.
I mean, you've said so many interesting things, but you've mentioned requirements, and that's one of the things I find kind of like linking these two worlds together is really important. The next generation of cloud education, we need to think about requirements differently. Because right now, if you look at kind of Amazon, the cloud providers, they'll say security is job zero. You know, you choose your requirements based off how secure it is, how resilient you want it, and how often you want to access it. And when you make those priorities and you say, I want 5 nines because that's what the book said, and that's what that said because of someone else, I just wonder, what can we do to view those requirements through a lens of sustainability?
Yeah, so, I mean, the first thing to consider there is actually what is your risk appetite for your IT, right? Now, I remember doing this, installing mini UPS systems in server rooms. And I always used to think, why are we putting these UPSs in, right? And it was basically, in the event of a power cut, these UPSs will provide enough power and send a signal to the server to invoke a graceful shutdown procedure, right? So all of the services that run in the server would shut down, and then the box would physically shut down, right? Waiting for somebody else to come back in once the power had been restored and press the button again, right? Because I feel if there's a power cut to a building, then nobody's be able to work because all the computers will be out as well. But it's all right for your server room to be humming away, providing service for people that can't access it, right? So it's a completely pointless exercise to do that, right?
Yeah, in the old days, I have to say, our UPS would quite often be the cause of our outages.
Indeed, indeed. So it's down to what actually happens in a disaster situation, right? If the power goes off to a city block, and you keep all your data centers running on backup services, why are you doing that? because nobody will be able to access it because their physical equipment that they're using to attach to your network cannot be powered because the power's out. Right? I used to work for BT, and I remember sitting in St. Botolph's Exchange, which is on the Aldgate Way system, which is an old telex exchange, right? And I was sitting there one day, and when usually, I mean, my ears are affected by it now, but the old click-clack of Strowger equipment, and it was incessant. It was a low buzz everywhere. One lunchtime, you could hear it start to go, right? And then there was silence. And I was like, I looked at my T1 and I said, what's happened? And he went, power cut in the city. Because telex machines were powered by the city offices. And it was their power that was powering the BT exchange.
I'm going to throw in a couple of things here, because you've said about electricity in the UK. And we don't have a central electricity generating board anymore. We've got capacity issues that we know. It's not only just balancing supply and demand, it's leading current, leading voltage issues. And we're cutting down on certain types of generators, which reduces inertia, physical mass, spinning disks, which creates resilience within the system. There's an awful lot of issues going on with the electricity grid, which you're familiar with as well. And I'm going to say, why on earth, in a world of, serverless, where we're heading towards a world of conversational programming, would I ever thinking about containers, Kubernetes, let alone hardware, let alone data centers, unless I'm a massive player? If I was going to give you 100 million and you came up to me and said, you're going to spend it all on building a data center, how am I going to react?
Well, I think you'd be a little disappointed with me. I would be a little disappointed with myself.
You would as well.
But yeah, I mean, as you say, you were a big fan of serverless, and actually that's, well, something you said earlier was that efficiency doesn't get us all the way in terms of sustainability. You also need energy, and I agree. In the long run, we are going to need energy.
More energy.
Growth requires energy, and growth isn't always about, growth is kids go to school, and old folk don't freeze to death in their homes and things like that. That requires energy. At the moment, we have the types of energy that seem to be on the ascendant are wind and solar. And nuclear one day will have that, but that's still probably quite a long way off. And batteries, great, but they still cost a lot. It costs a hell of a lot to store energy that's produced. You're much better off using it as it's produced, vastly, vastly better off. And that is the difference. Solar, wind, we need to have things that are not on demand. Therefore, the systems that we build, if they are utterly on demand, they're conflicting with how we're going to have loads of energy in the future.
There are, of course, not just chemical storage in terms of batteries.
Well, that's true.
You've got potential storage in terms of hydro.
It's true, but it's very energy undense compared to coal, compared to petrol, compared to
Well, I was going to. There are good points there, right? So we're currently looking at microgrids, right? So, and I think the problem we have, right? Actually, it's a problem from the past, right? So when old Swan developed his electric light bulb, and all the guys that were at the forefront of electricity, there was an old the guy that was in Hogwarts, the father of the Rupert and all those guys. He did a What Happened in the Industrial show that I used to watch, and apparently when one of the scientists, the electrical scientists, spoke to the government about the rollout of electricity, he said, eventually you can tax it. But up until that point, most electricity production was very, very local. And what we've done is we've centralised, right, into big power stations, littered the landscape with high tension pylons across areas of natural beauty. And now what we're seeing is a kind of return to that. We're looking at microgrids a little bit more in focus now. And data centers should do the same thing, right? So something's called software-defined data centers. So we create all of these ultra-resilient data centers with multiple systems for backup because we consider the data to be king. And it's only one instance of that data, right? But if we follow the Amazon view and the availability zones, and we do 3 data centers, and we have 3 different pieces of the same data residing in 3 different locations, then you can just strip out all of that additional stuff.
Why would I? If I'm building something for someone else, why put it's a bit like if I'm building a taxi firm, why worry about how to manufacture tires? I just buy the tires that I need, or I rent the cars that I need. It's where I should focus. So why in today's age? I first of all agree with microgrids, but we've got a big whole issue in terms of control systems.
I agree.
Yeah.
Well, that's number one. How can we get more microgrids?
That's a different issue, because we've got a whole issue about control systems and how we've designed the grid and all the rest of it. But in terms of data center, why bother?
But maybe we should be defining what microgrids are, because we've all said, oh, we all agree with microgrids. We might want to.
Well, hopefully I can try. But yeah, I guess it's about like looking at how we consume energy differently. Today we rely on the national grid, but we want to link up our homes to individual power generation. We might have batteries that charge our car, or even cars themselves that can push energy back into the home, and then
vehicle to grid.
Vehicle to grid, and then having that localized communities. And you know, one of the things I wanted to say before is like linking in serverless. It's like, okay, when we think about how we should build services, and you know, a lot of the time we prioritize speed or what we already know, and we end up containers and VMs, and we just throw what we've already got online, but we're not really rethinking how to do this in a serverless way. And that's really important for the future, especially with Anne mentioning sort of more renewable energy on the way, is this energy has, well, we have demand peaks in terms of the country, and we have to control the energy that comes out of these power sources. So with wind energy in particular, we slow those wind turbines down before it can get into the grid, especially when it's high demand. And the interesting thing about the clouds is if everything can be in terms of that serverless workloads, and it's resilient in terms of it can be run whenever you want it to be, that can be a solution to that, is in terms of you have these data centers attached to renewable energy, which would peak demand, especially for machine learning.
Why am I caring? Because if I'm writing in serverless, I mean, you're going to get Amazon eventually, because we've already got billing per function, so it won't be long before they have CO2 per function.
Say that. Actually, you say that, right? So we have done a very.
Hang on.
Okay.
It won't be long. Okay, we can argue over how many years, but not whether it's going to happen. But then the issue is, even with serverless, we're starting to look at prompt engineering. So it's even to the point of, I'm using large language models to help me connect services together. We saw an example of that at AWS reInvent with Jenkins back in 2018. I'm confused as to why do I fundamentally care anymore about data centers?
Well, as individuals, I think for me, why we go into understanding data centers is we have to understand the impact of what we build and how much data we store. For example, we're at a conference talking about open data, open source software, and open hardware. A lot of the time, the conversation in the past has definitely been around the software and the data. If we look at our trajectory of growth of data, we're expected to grow 25% year on year. And some estimates say, or there was a research piece that I came across that said, if we continue to grow with the amount of data that we want to own and store and consume, we'll need to mine a Mount Everest worth of materials just to store it each year.
Yeah, so I've got 2 points, one for Simon and one generally, right? So I was at the QE2 Centre just before Christmas, and there was a girl from the JET laboratory, right? So the Joint European Torus and Fusion. And she said that for the world to meet its 2050 net zero goals, right, we would have to build a power station every day from them until 2050, right? And that's clearly not going to happen, right? So, but coming back onto your element, Simon. So earlier you discussed the various hierarchies of stuff in your mapping, and you get to these high order systems, right? So let's assume that Bugatti Veyron, right, is the ultimate pinnacle of your high order system, right? A fantastic engineered motor car that can travel at exceptional speeds, right? Unless you look at the data center, right? Or in this case, the road that the Bugatti Veyron is running on, you're not going to get to achieve the speeds, because you're not going to get those speeds on a country road. You're not going to get the speeds that you require in the higher end of the cloud unless you have a robust, secure, energy efficient and sustainable data center platform for it all to run on.
I keep on coming back to, if I gave Anne 100 million, and Anne said, "I'm going to spend it all on a data center."
What would you actually
It'd be
do,
like,
though, and what would you build with 100 million? What
What would I do? What,
Yes.
Yeah. The data center of my dreams.
Oh no! What do you think we
I'll
need
tell you
to
what I
spend
would
100
do.
million
I'll tell you
on?
what I would do. I would buy 10,000 1 megawatt edge data centers and put a mesh network in.
Yeah.
That's what I would do.
I mean, that's really fascinating. I think for me, and part of the reason why I'm doing this is how can we affect culture change in technology? 100 million, where we change the minds of so many different people to be more efficient, care more, do things differently.
But it's interesting. Would I spend it on education, or would I? Because I'm immediately thinking, well, because I've been switched slightly to your microgrids point. So one of the things that we can do that's very efficient is we don't really want to be using loads and loads of giant batteries within the grid. But batteries in homes can be very efficient, paired with filling them up when there's a surplus of energy available, because you don't want to have to turn off your wind turbines or even your solar panels. A range of house batteries across the UK would massively stabilise the grid. And it feeds into that kind of microgrid way of working, where actually the energy stays closer to where it is, and batteries are getting cheaper and cheaper. So I might be looking at something like that, except that there aren't any batteries to buy because of supply chains.
I know, but I love this. So Anne's promoting here, we're going to build a business which does batteries at the home. Love that idea. But if you turn around and said, I'm going to spend 90 million building a data center rather than using Amazon or something, it's just like, it'd be crazy.
What would you spend 100 million on, Simon?
I certainly wouldn't be building a data center.
Okay, so you say that, right?
Unless
let's
I'm
use
Amazon.
right?
Unless
Hold
I'm
on.
Amazon.
Do you know how much a 100 megawatt Amazon data center would cost?
I have no idea.
1.5 billion.
Okay, great. That's.
So why should they spend it?
Why should they?
Why should they invest that money in? None of them have made a profit. No cloud company has made a profit for the last 10 years. The hyperscalers, right? Amazon lost 3 billion last year, right? Which is 2 of their data centers.
So, really interesting conversation, and I love it all, and I'm just conscious of time. The one thing I would say, if we just click the slide for me. This is the sort of thing we want to look at in terms of education and conversation and getting people to speak directly to experts like this to go, okay, what do we need to do? What do we need to do differently? And we are together doing a online course. It's a 3-week cohort-based course designed for executives, filled with workshops and, I guess, something special from each person that's involved, and hopefully that's the sort of thing where people who are in the decision-making powers, policymakers, experts, politicians, and executives in businesses can go, okay, what should I start caring about? But we've said a lot today. We've covered loads of different things. Who's got the questions for us so we can actually help you with understanding more of this?
I have a question.
Just wait for the microphone, yeah.
Hi, I'm Mike, and I was intrigued by your panel heading. So my question is then, well, actually, who are the disruptors transforming the next generation of our future data centers with this efficiency and sustainability? And do we have endless natural resources where we can build 65 million batteries that will go in all of our homes in the UK? There has to be some ROI, and the resources will eventually expire.
I mean, that's a very good question, actually. So as I said earlier, we're working with the largest data center construction project in Europe at the moment, which is just shade under 500 megawatts of IT load in Portugal. And they have got 5 gigawatts of solar, right, to support that. They haven't got interesting enough, they haven't looked at a battery solution yet, right? But they are using some innovative seawater cooling. So they're located next to the LNG terminal for Portugal. So they're bringing in all of the natural gas from America and Mexico, etc. And they use ocean seawater to cool the liquid LNG so it can be put through the pipelines. And the data center is actually using the outflow of that now super cooled water to cool the data center. So this is one thing. But I said earlier about the somebody else's problem field, right? There is a massive engineering consultancy, global engineering consultancy, that's helping them build this, right? Because it is the largest one. And when I suggested a few things, so I suggested the use of hemp, as an industrial hemp, as a replacement for some of the panels inside the data center. And they kind of looked at me as if I'd said, I want you to start up a cannabis farm. and I just thought, and I've done some research on hemp, right? And it really is a magic bullet when you think about it, right? Because you can plant hemp on an old industrial site, and it will literally pull up the contaminants from the site, and it can reclaim a former chemical works in 3 years. Right? This is the sort of stuff that this can do. Then when you look at the actual hemp itself, you can make it into all sorts of different things. You can see soaps, you can do clothing, you can make these panels, it can be insulants, it can be corrugated roofing, right? It is a wonder product, and yet the major consultancies are not even considering it. And bearing in mind that a lot of the US states have now released it for medical marijuana and recreational marijuana, so there is lots of plantations going on, and you cannot transport waste products across state lines. What's happening is inside states, they are using hemp as building materials.
Just in conscious of time, go on.
Mic so that it's part of the stream.
I completely agree with you, John. Hemp is a magical material.
Yeah.
So why aren't attitudes changed towards it then? And how do you change the attitudes? You're the experts. How do we do that?
Yeah, why don't we move? Yeah, why don't we take another question?
I'm the host, and thank you, Eric, for helping. One thing I would say is I released a podcast recently called "The Infinite Cloud is a Fantasy," and that was from a researcher called Steven Gonzalez, who calls himself a cloud anthropologist. And one of the fascinating things we talked about then, we've talked about the role of Amazon and data centers and what we prioritize and what our things are. One of the fascinating things is, where do tax breaks exist? And where do we see data centers? And that's the sort of thing when we prioritize things and why we do innovation, a lot of it revolves around just the way we do things now, how much money I want to make, rather than these other innovative questions. Some of the interesting things I've found in cloud is go on, Anne.
I'll just add something about something that you said earlier, and then you were asking about the innovations in data centers. One of the places in the world where there is most totally on-demand, constant, free energy is Greenland. Because water is melting off the ice caps, and it always has, but it's even more now than it has been in the past. But there's no one there to do. There's no skills there. There's nothing there to build this stuff. So there's a huge amount of potential resource there that is not being used at all because of the lack of the infrastructure around it and the people.
And this is one of the reasons we created the Academy, because we want to educate people into, and it's the National Data Center Academy, and we're looking at it in two ways, right? We're saying, right, this is how we build them now, right? So this is when you walk onto a data center site, this is what you will see. Mm-hmm. But really, what you want to be looking at is this, which are multiple input sources from energy, right? So bringing in the concept of microgrids, then using the waste heat, right? And you can use the waste heat for other products, right? So we've seen this in Norway already. There is a lobster farm, right? Because apparently lobsters have fun between 20 and 22 degrees, which happens to be the temperature of the outlet water from a data center, right? So they've created this lobster hatchery. There's also a fish farm, which the same thing happens. The fish get frisky at that sort of temperature as well. So they're doing all this sort of stuff. And this is farmed food, right? But then there's, we were in Mauritius. We were looking at the immersed compute product. You can fix dyes at 40 degrees, right? So when the output of the data center is heat is at 40 degrees, which it can be from immersed, you've got natural, and so they don't have to create water that's 40 degrees. They've got it through a secondary process. Cleaning materials for food prep, right?
Just conscious of keeping to questions. Well,
I've got
more.
to say, from contaminated hemp to frisky lobsters, I mean, those are some pretty interesting arguments for the data center industry. I've got to say, with limited constraints and resources and materials, there's going to have to be a concentration of effort. I think the greatest innovators in this space are almost certainly going to be Amazon, Microsoft, and Google. For me, the biggest issue is whether they should be nationalized in some way or not, because actually it should be basically a industrialized service. And maybe, when we talk about nationalization, it should be on a global scale. You're seeing this in in China. We're certainly not doing this in Western countries, but I would, I struggle to see the advantage of everybody homegrown.
30 seconds.
Very quickly before we finish, but I am a proponent of what you said, right? And I would say that data centers need to be considered to be the fourth utility, right? And they need to be regulated the same way as electricity, water, and gas are. But they would scream at that. But actually, what's happening is at EU level, this legislation is coming in under the back door, right? But they are going to be heavily regulated, probably from 2025 onwards.
And yeah, we've seen it elsewhere. I think Simon was going to say China. I mean, China basically said, yeah, you can do cloud in our country, but we own the data centers and you can run your software on top. And that's the power that we can have with regulation if they want to access a market. And more individual countries should be turning around with regulations and say, well, yeah, run the cloud, but here's our lines, here's the things we need for a future.
When things become common infrastructure, that is, so it's interesting because when we talk about economic systems, market system versus centrally planned, market systems are very good for the genesis of the novel and new. They're pretty good for product development. But when you get to the point of common infrastructure, this is actually where nationalization, heavy regulation, and much more central planning. And we miss this. CEGB, for example, is a big loss.
And it would be lovely, I agree with you, but I can't get it, but moving
relationship.
It can't get in the way of us actually moving forward because it could take decades.
Yes, that's true.
It's interesting because I run a podcast and now you're saying we should have nationalized and utility-based cloud. The podcast is called Public Cloud for Public Good. And if we thought about what we could do with a publicly owned data center service or 100 million or whatever it is, countries could go, okay, well, it's a utility that, or even governments or EU, we just say.
I think that's inevitable, Aaron, to be honest. I mean, we're already seeing, John spoke about moratoriums in his panel session. People are reacting. They don't want data centers being built in backyards. So we've got Dublin's got a moratorium, Singapore had a moratorium, Amsterdam's got a moratorium. So these facilities, in order to maintain our online world, right, we need data centers. So it really depends on where they go and what we do with them.
Differently. Well, thank you everyone today. It's been a really interesting panel, and I'm just conscious I'm either going to have to put our slots in the course for much longer, or avoid some people talking for too much. But it's so fascinating. No, I don't mean that. I do wonder how we bottle it, how we capture it, how we focus these things, and how we really go, okay, here's some of the real stuff. And well, it's been so fascinating, amazing, and I've had so much fun and learned about hemp, lobsters, and so many different things. And thank you so much, everyone. It's been great.
Pleasure.
Thank you.
Good to see you.
If anybody's interested, there's actually a company called Unite, which is looking at the hemp industry in the UK, and that's from actually assisting farmers with the licenses and the crop growing all the way through to the processing of the items and then the resale of the products that they've got. So that's interesting. I mean, I only recently discovered it by chance, and I just thought we've had a few.
Have to start dragging you off the stage because, as the conference organizer,
Oh, right, okay.
somebody else is about.
Oh no, there's a break. There's a break.
There's a break.
You can mill around.
Isn't it? Oh, is it
No, it's their afternoon break. So it wasn't. That's how you.
I'm seeing a lot of happy faces from the audience. Great, sounds on. So,
yeah, go ahead.
We'll get going. So first thing, I think we'll take questions at the end, probably the easiest, having seen some of the other talks. So we're going to talk about automated testing with open source hardware. So quick introduction. The who part is quite easy. We're CodeThink, we'll talk about that in a second. Why? Well, hopefully everybody here thinks that testing is a necessity for good software, and that when you have testing, automating it is even a better idea. So as a consultancy group, we're often testing software that gets deployed to an actual, oh, we've got more people coming in. Hello, more audience. So as a consultancy, we're often testing software that is deployed to hardware. So we'll go through a bit about some testing overview, virtual versus real testing, some open source tools to run your testing, and our journey through to actually why we ended up making some real world testing tooling. So quick bit about CodeThink. We're open source software experts, at least that's what our marketing says. We've been enabling customers open source innovation for nearly 16 years. So I've been around the open source for a long time. So not only do we do work for hire, we're also involved in various open communities. So if you've heard of the ELISA project, that's focusing on safety in Linux. And we're also involved in a lot of long-term maintenance projects, such as a civil infrastructure project, which is another reason why we think testing is good, because obviously those projects need good testing. So about the speakers, so I'm Ben, kernel hacker, system software expert. I also like doing electronics. And here we have my colleague Mudit.
Hello.
He's also one of our software engineers and another electronics expert. He also likes embedded systems. I mean, who wouldn't? So, we said already, testing, we all need to test our software to ensure the quality for everybody involved. There's been a lot of work around automated testing, and we're going to talk about the tooling we're going to do and why this is useful for reducing the need for manual tests. So, as a software consultancy, we often have a quest to improve software quality for everybody, and through continuous integration and testing, we think that's the best way to go. I mean, humans are not the best at testing things, and certainly it's very difficult to actually clone the best testing people. So manual testing is difficult to apply to fast-moving projects. So things like Linux kernel, where you've got a lot of code, is difficult to do manual testing on. We can improve the granularity. So often we found that manual testing involves people, and often this is only done on a branch merge or something similar sort of time frame. If we can automate even some of the tests, we can get down to like pre-branch merge or even per commit testing granularity. This we found often improves the software experience because we get the errors earlier. We've also found that in the manual testing that you may not always spot mistakes. So testers may not have complete knowledge of different languages. So, and as mentioned earlier, certainly with long-term projects, repetition of testing gets to the point where you just can't keep doing it manually. So, I mean, we're going to talk about automated testing on hardware, but we decided to have a quick say about the virtualized. So you can use emulators such as QEMU to emulate most of your hardware, but the first issue is generally complete accuracy. You may not be able to model your hardware, or you have a complex setup. So often we find when customers' products need to talk to something other like a phone, those cannot be easily emulated by anything currently. However, it is also easier to scale your virtual testing, so it can be part of a testing cycle. It might find some basic errors, and it's easier to integrate into your CI. So, you're also going to need testing tools, so part of that is going to be the software. So, OpenQA is at the heart of projects such as OpenSUSE. They use it for installation testing. It can do screenshot matching, input event, so it allows testing from your first boot all the way up to actually functioning desktop. So you can use it to test things like, does your desktop have a movie player? We've used it in conjunction with real hardware to provide very similar testing of, does the customer's UI work? So that's something we talked about at FOSDEM last year, and the talk is available, a link in the slides. So Lava, that's something that Linara have built for doing test scheduling and test frameworks. This is often used in projects such as kernel CI. It can be used for scheduling and capturing tests. So, very quick introduction to testing. So now we'll go through some work with actually building our test setups. So we're going to be looking at how we would make a hardware test rig and give some overviews of the type of hardware you can use to control items in that rig. So things like relays, things to control direction of hardware connection, like hardware muxes. We've got specialist network bridges and I/O capture, so things all the way from simple logic analyzers up to something which will capture images. We can't go through all of these, obviously, but the beauty of a lot of these open source projects is that there's so many to choose from. And as I think we'll go through in a bit, it's becoming a lot easier to build these systems. So we can use relays, which are simple electrical controls, to do things like simulate a power button, control power through the system. There are also open source software tools that allow you to control power delivery units. So things like from just a simple plug relay unit that you might find from a shop all the way up to data center control. PDU daemon generally allows you to do that. And of course, if you really want to annoy your fellow developers, you can make clicky noises. Very good. I didn't put a picture in here because generally there are so many variants of relays that it's difficult to choose. They're not always open source, but the software to control them is often. And you can make your own, but generally they are so cheap and available nowadays that you may as well just buy something off the shelf unless you need anything really complex, when of course you can go and make your own thing. So a lot of systems now have some sort of networking, so you can either have Ethernet or in this case CAN bus. So CAN bus is very popular for automotive and some other industrial. And here we have a USB to CAN bridge that somebody has built. It's called the Cannibal. Again, seem to be that bad puns are obviously rife in this area. So this example would be used to say if you needed to inject control messages into a test system, if you're doing, as we do, a lot of work around the automotive. So very useful for that, and you can also use it to listen for messages as well. Again, that's just an example of how some sort of specialist network can be used. This is one I'm quite interested in. So micro SD cards are very useful for storage. You might, as part of your test, want to reflash a new image. So at the top is an initial version of the Tizen SD card MUX. I believe when I actually got through reading all the documentation, it says don't use it. Apparently there was problems. But they produced a second version, so the one on the bottom is a micro SD card MUX. I don't think you can't, the micro SD card is underneath it, but it has basically a little micro SD-like connector, so you can plug it in and switch between having the micro SD card connected to your device or to a USB to SD bridge, and you can then just reprogram it, which is great if you want to put a new image on the system. Lastly, so for higher speed systems, this is the Yuzuki HDMI capture board. So HDMI comes in, it gets copied out and to a capture device and to USB-C. So again, this is a thing you could just download and make yourself. So how could we put this stuff together? So this is a very simple test rig that we've been using to test a Sci-Fi unmatched board. In this case, at the top is a Raspberry Pi. We find this is often the best way to isolate the system from our main network, and it means that you can put test images on, use a USB network to connect to the board, USB serial for the console, and if you can just see up there, there's a USB relay board taped into the case. That allows to control the power and reset switches so that if you need to reset or power down the board, you can just flip it through. This one has been thoroughly developed and has had its USB slot fixed. I can recommend that some software engineers are not allowed near boards. So in this case, we use this as part of our kernel CI. So we're involved in testing kernels. So the CI system downloads a new kernel, builds it, installs it, does all the necessary resetting to get the output, and then runs some validation tests to see if, firstly, does the board boot, and then if so, can you then log in? So I'm not sure if we've actually found any major bugs during this, but we found some issues around PCI initialization and stuff like that. So this is more of a more complex system we've done for a customer. This test rig has a lot of things like CAN, other specialized stuff. We connect it to, again, something like a Pi to control it, control all the inputs and outputs, run up our software, get the test back from it. Our test people wanted to show a little bit of the test infrastructure, so we start from some software through a GitLab runner, Docker container with the OpenQA client, so it gets some tests, initiates some tests on the thing, gets some results. So for this customer, this is one of the examples of people who were doing a lot of manual testing, and we have much improved their experience by automating this all out. So what have we got from our experience of doing this? So if anybody's been doing electronic design, a lot of modern systems are now using high-speed signaling, often high-speed differential signaling. This has some issues around the limitation of parts available to do whatever you wanted. We'll explain that in a minute. There's also issues around doing layout. So one of the things we found with the later KiCads is that the layout tools have got a lot better. So matched length routing and things like that. It puts lovely little squiggles into your board, and we'll show some of that later. So we'll show you something we've designed with some modern design tools like KiCad in the next section. Even though you might have an open source product, some of the protocols involved in the projects we've been involved with are not open. Well, sucks to be you. You're going to end up implementing your own stuff there. Even worse, your customers may use closed protocols with even the strangest of connectors. If anybody's done any work in the automotive world, they absolutely love a proliferation of different connectors. And even something that looks like its little cousin, it might be a different color, which means it's a different mating. So that just makes it even worse. Also, there's industry-specific protocols, well, almost. So things like broad reach are often only found in automotive, which means that you either have to do your own thing or buy somebody's expensive solution. So that sucks even more. And this comes to one of the big problems we've found when actually trying to do this sort of stuff is availability of parts. So we had a customer with an automotive Ethernet. We wanted to do 100 base T to automotive connection. And we were initially just going to buy something off the shelf. We looked around and there was nothing. Everybody who even had a vague product said, no, can't buy them. So we thought, great, we'll do something ourselves. And then we ran into exactly why this was the case, because anybody who sold a converter chip for this protocol didn't have any. There was none in stock, and they were quoting lead times in months. So that is one issue that open source is not going to get around for you. So at this point, we've gone through some of the overview, some of our experiences. This has led us on to actually a more successful project that we've done, where we've gone from there's a specific need and we've gone through and actually created something. So at this point, we'll hand over to Mudit.
Right. Thanks, Ben. So I think by now we all can agree on the fact that testing is necessary. There's no two ways about it. First, critically, automated testing is crucial to make sure the reliability and safety of our products, as it helps us save time and resources in general, like time is money in that sense, and making our test equipment and entirely our test hardware more accessible, and having test reproducibility. That's quite key. So most of us here are already aware of the importance of testing. I mean, if you've worked with tech before, we all know how crucial testing can be. And as a consultancy, we get to work with various customers and examine different software infrastructures. And we observe a common pattern. So whenever a customer wants to develop a product, majority of the resources are spent on development, and testing infrastructure is usually an afterthought, something always on the back burner. So having various product-based clients, we have understood the genuine underlying reason behind it, which is the focus and priority of a customer or the client to have a working product. So we know tech move fast, and companies want reasonably quick turnaround times, which tempts companies to use quick-to-set-up test methods, like manual testing. Quite quick to set up, right? Like you just employ people, have your test rig set up, and tell them what to do, and they do it. Quite easy to set up. They also end up employ solutions that are quick to hack together and reasonably cheap, but for small-scale execution. So once you have, in the general product development lifecycle, the design happens, development happens, testing happens quite quickly, and then release happens, right? Now, after release, we've hacked together this test infrastructure. Now, that test infrastructure remains the same, and the entire dev team, after release, goes to work on the upcoming new feature. Now, after that new feature, people start to work on a new feature, they again have to go to the test infrastructure again, which is hacked together in the first feature. And what does it lead to? So this constant neglect of the overall weak test infrastructure will end up with a testing strategy which is hard to maintain, expensive to run, but will also be expensive to replace with more and more effort that gets put into the initial weak testing infrastructure. So at GoThink, we've had many clients who have found themselves in similar situations, and we saw a recurring issue with testing software and hardware integrations. So here's an example of a test case. So we had a client, automotive client, who were employing a testing methodology where they had testing room with many rigs, and they had 17 engineers with a spreadsheet, and iPhones, thumb drives, and Android phones testing our Apple Pay, Android Auto, and just making sure if everything works and making sure they tick on the spreadsheets if things are connecting or not connecting or whatever they have it. So we were like, well, we all can agree that this is not a scalable solution at all. It will not scale well. So we were like, well, we can definitely solve this problem, but as Ben already mentioned, the existing hardware that exists either is not firstly something that we can automate, or it's very expensive. It has all the bells and whistles we do not need, and ends up being quite expensive. So we were like, well, we'll find something that already exists. So we could find switches, USB 3 switches, which were manual with a button on them, not something you can programmatically control. So what we did was we bought a few of them, right? We ripped off the switches from them, the buttons on them, and we used a microcontroller to interact with them and have a workable solution. So we just about managed to automate the process. But, that is something that you don't put on rigs that are just going to be shoved at the back of the room somewhere. So we're like, we could actually use this, you could see this is an existing issue. We've seen this with various other clients, and we were like, we can make something more robust, which not only helps our existing clients, but also it helps us help the community in general. So we built our own USB switch. Show off. So what does it do? Essentially, it's a USB-C switcher, which helps you connect one peripheral to multiple hosts, or connect one host to multiple peripherals. It's USB-C and bidirectional. So on the product diagram on the right, you can see that we have DFPs, UFPs. First of all ports are USB-C. DFP stands for downward-facing port, which is usually the host port. And we have the UFP, upward-facing port, which is usually the peripheral ports. You can send AT commands over the controller USB-C port connected to your laptop or your CRN or whatever you like. And send AT commands. You can switch between connections from each port. It also has power switching, so you can actually control the direction of flow of current from each port, or have it bidirectional or completely turned off. Now, the reason behind this design choice was to make sure if somebody is developing test USB hardware, they should have the ability to turn stuff on and off. Considering we have USB-C ports with the power delivery specification, with the latest one, you can have something up to 240 watts being negotiated between each port. And if you're developing hardware, you're testing stuff, I think the developer should have the ability to turn off power if required, or make it unidirectional for safe testing. So that's why we did that. We designed the PCB of the hardware in KiCad 6. It's quite intuitive software to use. It's come quite a long way. Easy to use. I would say it's quite beginner friendly. We wrote the firmware using ST's toolchain. We use an STM32 F103, yes. And the case were designed using Fusion 360. So what you can use it for, basically anything that involves you to disconnect or reconnect devices, switch between devices, or actually have a USB device move between multiple hosts. In essential testing automation, that is what we actually wanted to achieve with this product. So with any sort of development, there's always chances of errors, and we have counted a fair share of issues ourselves. So with the first revision of our hardware, firstly it took 10 days to develop. We sent out the first revision of our hardware after doing 10 days of development. So we received the hardware, we plugged it in, and we realized that the power switching is not working. And we did some few testing, and we realized that the diodes were the wrong way around. So I fired up KiCad again, and I was like, it looks fine in the circuitry. What's gone wrong? So I put the PCB and the schematic side by side, realized, well, the diodes were flipped. So the reason behind that was it was a common assumption to be made, right? If you use standard KiCad libraries for the footprint and the symbol, and we just assumed that the pins and pads would align, but that wasn't the case. So we learned the lesson that way, and it was a quick fix. So the second issue we were having was with the USB-C orientation. So as I showed you in my previous slide, that we have USB-C female ports on each end of the switch. So a USB-C female receptacle has CC1 and CC2 lines, but a male plug has only one CC line. And when we use a USB-C to USB-C cable, that will also have a single CC line. So what could happen is you could connect a USB-C thumb drive on one end, and that might have the CC line of that peripheral on one, or maybe CC1. And on the other hand, when you connect the switch to an actual computer, that might have the CC line on the CC2. So we'll have a CC line misalignment, and that would not cause the device to enumerate. So that is an issue that we've seen. We could call it a feature or something that we put in our notes in our GitHub repositories to make sure that when people are using it, they make sure that it might be a possibility. When you plug in a cable one way or the other, it might not work. But we want to actually fix this in a much better fashion, so to make it as plug and play as possible. So we've had, as I mentioned already, that orientation issue is something that we're still working on, making sure that it's as plug and play as possible. And we've already done design review for the next revision, which is going to be the DrevC. And so from what you saw in the diagram, the PCB itself still quite a lot looks like a dev board. We have the debug ports and everything on there. We added them intentionally in the first two revisions to make sure that once you're writing firmware, we can make sure every pin is doing what it's supposed to do. But now we're quite confident with our firmware, so we can simply get rid of those debug ports, actually make the footprint of the PCB much smaller, so it looks more of a commercial product. And we also improved the power switching circuitry, the efficiency of it. And currently, with the RevBs, we don't do the S-bus line switching, so we can't really get DisplayPort out of the switch at the moment, but that's something we're going to do in the next revision as well. So why did we actually choose to open source the entire project? The reason behind that is Goldthing is not really a hardware manufacturer. We saw an issue that multiple automotive clients have had. We've made a solution, and we're like, this thing can actually help many. It's not just automotive clients or people who make automotive stuff. It could be some people who just want employed making hardware, making hardware, testing, integration from software to hardware, whatever have it. So that's why we made it open source. And at Goldthing, we also want to enable better quality and robust test infrastructure. And I think this fits quite well with providing tools to be able to have robust testing infrastructure in general. So what all is free to use? So the hardware is completely open sourced under the CERN open hardware licensing. Firmware, we use ST's tooling, so we can't really call it open source. It's freely available for you to use and then flash on your boards. The case was designed using Fusion 360, so we distribute the STL files for 3D printing, and it's under CC Commons by SW. I hope I said it right. So if you really want to get one of the switches yourself, you can scan the QR code. We have a GitLab that sets you to the project. All you have to do is you go to the hardware project, you get the files, download it, send it to your PCB manufacturer, whichever one you like. Once you do that, once you have the hardware, everything assembled, you go to the firmware project, flash the firmware using an ST-Link, print a 3D, print the case, and to secure your hardware. And there you have it. That's all you need to make a board for yourself. So the bigger picture for Goldthing then, this is where does Code think as a company actually want to go with having open source hardware for testing, for automated testing? What is the bigger picture? So at CodeThink, we want to enable availability of safe software, and that is not quite possible without ample testing, essentially. We want to make sure people test their code, and that makes everybody's lives easier. So for that, we want to make tools for testing infrastructure more accessible, which are easy and quick to set up. Because if you have something like that connected to your CI runner, you can simply just plug and play, and there's no more manual testing involved, so it's more repeatable in that sense. And it's quite hard to actually change path of least resistance when it comes to development. We do really want people to not change the way they already make or develop software or hardware. We just want to make sure we provide tooling that makes the existing workflow that they have more efficient. So if we are able to provide more tools in general, it just makes everybody's software infrastructure more better. Maybe it's open source, maybe it's commercial, whatever it is. It does help to improve the existing workload people have. So that's the motive of CodeThink, provide genius wherever possible and make good testing infrastructure more accessible. So that'll be it from us. Any questions?
It's on, yeah. Just go.
Yeah, the first question would be, and maybe the main question, with regards to the power distribution, delivery, and consumption. So USB-C provides the power delivery negotiation protocol, and if you go to upper voltages, what's the amperage of the board? Will it be able to power delivery for all the output ports, and does it provide the short circuit protection? So like all those problems that you're struggling with in a real test environment. Thank you.
So in a sense, we basically it's like a cable that switches from one port to the other. So the hardware that we have is suitable for up to 100 watts. So if you want to do power delivery, not the extended range, but the standard range, is capable of that. We've tested, we've plugged in laptops which can do power delivery, which can negotiate to 100 watts of power. That usually does work. But in terms of short circuit protection, if you would like to elaborate a bit on that. So short circuit protection, you mentioned that.
Short
circuit.
Yeah.
If I'll short circuit the output port, or if I'll short circuit the output port or input port, does it like boil the whole system, or the only port will be switched off, or would it be fried? And what are the timings for this?
So if you have it set up in a unidirectional mode, of course power is not going to go on the other way around. So it's unidirectional. So in that case, you're not going to fry the peripheral, the host in that sense, right? But again, with any consumer device, if you're connecting two devices together, and if you want to short, it's usually the host that should have protection. As I said before, this device just provides switching capabilities between it's like very much like a software-defined cable which switches from one port to the other. So yes, if somebody wants to really break something, it will break. But then the actual idea is to be able to switch between one port to the other. No, that sense.
So I'll follow up a little bit on that. Yeah, we had some design decisions internally about how much protection should be on there. We've been trying to make something as simple as possible. We could look at a version with some sort of electronic fuse. It's all something we did discuss. However, you are free to take this and add your own if you like. And I mean, if you want to, that's your own thing. This is sort of the beauty of the open projects we're dealing with, is you can take it and customize it to your own use.
Yeah, and the last question with regards to the power distribution is, it would be really nice having some kind of analog to digital converter, or digitalized, or like with a small, like, you know, the 7-digit screen showing up the amperage, and like it's a simple USB doctor device that you can buy for $1, but it can be incorporated in such a device. It would be really a cool feature to observe. Thank you.
Anybody else?
I mean, we're just going to follow up.
Oh, sorry. If you want to follow up, yeah.
We did look at
I'm
some
trying to answer. My fault.
basic protection chips that also provided some sort of current analysis. Again, this is something we may or may not do in a future revision. Adding a screen was, I think, a bit overkill. I think we mentioned the price roughly at the moment is about £17.
So 17 quid a piece for Rev B, but again, like in the future revision, we want to make it smaller and get a few bits out of it as well. So that'll get the price lower as well. The Rev C.
And just reminded me of something of the revision B where you forgot to refill the design files.
Oh, yeah.
Yeah. USB tracks don't go very well through solid planes of copper. Yeah.
You mentioned the debug port. You want to get rid of it, but probably it's not the best idea for hardware guys, because I am a geeky. I want to see what's going on there. I want to be connected and to manipulate stuff. Thank you.
The thing is, that's for revision C that we're going to do. We'll take it out, but then again, you'll still have access to the previous revisions.
Yep.
So it's all in a Git repo, so, you know.
You can add your own ports. I mean, I think if you've seen our prototype, I think somebody basically went, let's put a Raspberry Pi style connector on it, and about half of those pins aren't actually connected. So we could lose quite a bit of space from this board and still have some pins. It's still entirely possible we may leave some on.
Yeah, this is still a functional board. I mean, it will still be always available. So if you make a new revision, it will be more about like having something smaller. So basically doing what it says on the tin. But then again, if you really wanted that, it will all be available for you to order or use or modify as you like.
We have to be a little bit pragmatic about what happens. Obviously, we want to build these for our own use, and we have clients already using them in their test setups. We did also consider adding a second port to allow just switching the power delivery, so that if the port that isn't being used for testing could be used to power something up, just to, say, charge a phone. Again, somebody could come along and do that later. It's not entirely impossible. We don't produce a revision 2. So.
I just a quick final question. What would you say? Would you say the overall design cycle time? Like how long from when you're like, we need this thing to you have this thing in your hand?
So for Rev A, we took around 10 days. So first revision, and then again we have lead times on hardware. So it took 2 weeks to come from China. We got that. Then we made a few issues there, fixed it around 5-6 days. Then got the Rev B out, so that's Rev B right there. And now we're going to have a few more days of making Rev C. It was already in process, but then we started in mid-December last year, and now we're early February. So
okay, so 7 weeks, kind of end to end, including having the widget.
I mean, some of that was arguing about open source licenses.
Yes.
I mean, we actually just published the Git repo, I think, was it yesterday?
Yesterday, yeah.
Yeah, I mean, it would have been a bit silly to turn up to a talk about open hardware without actually opening the hardware.
But you wouldn't be the first.
Yeah, I say there's been some of the development time has more been debating about what actual features we wanted. So overall, it's been, I mean, it's not the worst hardware project we've done. I mean, we've done internal stuff just to make test boards for our customers, and this has been quite easy.
Beautiful. Thanks a lot, guys.
Thank you.
Yeah. All right. Is Jakub here for the last talk? You could seat Milena for a second and get the mic. I can take your laptop if you want. Or yeah, we have time. We have time. Just get the mic first. Thanks, guys. Thank you so much. Thanks for sharing.
the AirPods Pro. I don't know. Oh, I have the AirPods. I won also the AirPods Pro.
What, he won prizes here?
I won 2 prizes.
What?
One from GitHub and one from Neon something and.
Man, was it skill or luck?
A little bit of both.
Okay. Oh, I see. So you had to do something for the thing.
Yeah, but it was easy. Is it on already? No.
It's on. Yeah, she'll switch it on when we.
Yeah, sure.
When we're ready.
Yeah, sure.
So, why don't we start?
Yeah, we're good to go. Okay. Just reset my timer.
Sorry. So Jakob, our last speaker for the day, apparently very lucky and very skilled at conference events. So he's going to tell us about FPGA packet capture. So we're happy to be educated late in the day. Appreciate everyone spending the time to stick around.
Big thank you for staying this long because it's late. So maybe before I begin, how many of you are technical? Hands up. Great. How many of you have had experience with FPGAs? Yeah, cool. So we're good to go. So the topic of the presentation is FPGA-accelerated packet capture, or how to do it efficiently on SOC FPGA chips, like, for example, DE0 Nano SOC, which I used for this project. So here you can see the outline. It's not really long. Who am I? First of all, I'm a developer that's currently doing 5G stuff, L1 layer at Tieto, but I'm contracted for Intel, so it's like a word of contracting. I did some work at Samsung. I also did GPGPU with BeagleBoard organization on GPGPU acceleration during Google Summer of Code. I also recently graduated. I'm also leading a team of skilled engineers at Tieto. And that's what I do. I do some sports and basically try to smile. Problem statement. So first of all, why should we even care about offloading anything like packet capturing to hardware? Is it sustainable? Is it feasible? So the answer is it depends. Like everything you should measure, but I believe that as you'll see in a moment, or everyone already knows, that we have a rise in IoT devices. Recently, we've been having more and more devices that are equipped with FPGAs. So and SOCs, like there is one that utilizes Cortex M4A, I think, and has an eFPGA. So this is growing. So that's maybe a good time to jump on the wagon. You can see the numbers here that basically the data number is, the amount of data is rising, the IoT, the number of IoT devices is also rising, but we all know that. So, and basically there is not many good resources on how to accelerate, want to accelerate, and when to accelerate. So this talk aims to fill that hole a little bit. So here you can see 3 main, let's say, types of devices that you can accelerate on, especially network processing. So for the CPU world, we have DPDK. I don't know how many of you have some experience with that. Yeah, it's a niche topic, but So as for GPU, we have 2 state-of-the-art accelerators, Packet Shader and APU Net. I will link some resources later. And for the FPGAs, we currently have smart NICs on the market, which are smart network interface cards that usually use a kind of ASIC that's application-specific integrated circuit. And yeah, a little bit of Flex Run, that's the project I'm working on, and we're using the PDK at Intel. So how embedded networking is different from regular one? We use less power-hungry protocols, simpler ones like MQTT or CoAP. We also have less powerful hardware and software running on the chips. And we usually don't have the possibility to use a full-blown Linux distribution. Usually it's some kind of RTOS or non-real-time operating system like TOC. I don't know if you know it, but it has been rising in popularity. But here we'll focus on embedded networking on Linux. So yeah, that's basically that's my ugly diagram. I made it by myself. So as you can see, that's like a very overly simple diagram of how networking is done in Linux. So we get a packet on Ethernet network interface card, then there is a ring buffer, and the packet is read when the interrupt fires. The driver gets the packet, and then the NAPI, which stands for New API in Linux net systems, starts to work. And where I hooked in is on the BPF virtual machine, eBPF. So there I hook in a small XDP program that redirects the packet to the FPGA. So that's basically how it works from the networking side. Yeah, so here I've been using Intel Avalon MM protocol, or Altera Avalon, depends. And most importantly, what I want you to take away from this is that I use bursting capabilities because it makes the processing much more efficient. So how many of you know what bursting is, maybe? Yeah, okay, so it's just delivering data in batches so that it's just more efficient, not processing one by one and wasting cycles. So yeah, as I mentioned already, there is not much relevant work yet. So this might be an opportunity to dig into it. Most of the knowledge I've been searching for is ephemeral, and the buzz factor is just rising as not many people are taking up the mantle anymore, and they want to do easier things. So that's why we need good documentation and yeah, just efforts like this, I believe. And if you are into network acceleration, then you probably know about RDMA, which stands for Remote Direct Memory Access. And it's used extensively on smart NICs. So yeah. Here you have some 3 state-of-the-art works that I've been investigating to see how much traction is there on the topic. I won't go into details. You can look it up later in the presentation slides, but spoiler alert, offloading in all all three of these cases is efficient. So yeah, let's maybe go to the system overview. So as you can see in the diagram, we have three main boxes. So we have the Linux kernel, the user space, and the FPGA part. Just a quick reminder, in the SOC that we're using, we have the ARM CPU on the same chip that the FPGA is, so we don't have relative delays, not really big. So, I mean, there are some, but let's skip them for now. And in the diagram, you can see that the packet can go either through the eBPF VM subsystem and return with pass, then go through the entire net subsystem and be processed and then be delivered to the user. Then the user can take the packet out using, for example, TCP dump or some other capturing program and save the result in a pickup file. In my case, I decided to hack the driver, and I returned the XDP capture return code, which I added, and then the FPGA kicks in, and basically what it does is it's just a data moving machine, which seems to be pretty simple, but in turn turned to be out not that simple. I'll just go into more details in a while. So yeah, some modifications. Since I was using Intel Quartus IDE, I had to integrate it with the proprietary toolchain here and add some device tree entries. First one is for the pre-reserved buffer in the RAM that is shared between the FPGA and the kernel, so the kernel doesn't work on this memory. And I also added the device on the right. The test environment was pretty simple. I just had a host PC, which was tethered via an Ethernet cable to the target board, which is running, as you can see, D0 Nano SoC and two flavors of Linux kernel and bootloader, which are especially patched for this board. And the root file system was not built by Yocto, surprised. It was built by buildroot. But it might be built by Yocto, so we'll see. The test procedure was pretty simple, so we just can set the parameters, then recompile it, load the XDP program, start the test, which in my case was just pinging with some kind of interval between consecutive packets and then capturing the tracing output. And finally, calculating the deltas that it took to process the packets, starting from their entry to the kernel, finishing with the time when they were when the FPGA returned that the processing is done. So yeah, here you can see the driver patch, which actually is not that complex. On the left, all the code will be available in the, it's available on GitHub, but it also is available, the presentation online. So I won't go into many details here, but on the left, there is driver initialization, and on the right, we have STM-MAC XDP run prog, which is the hook that's run whenever XDP is triggered on the well, in the kernel, basically. So whenever a packet comes, the XDP program runs, and in this case, we fall into case 5, which stands for XDP FPGA capture that I added, and we do some. We pass the packet to the kernel, to the FPGA. I'm sorry. So here you can see the read controller module. As you can see, it's circled in green on the right, and I mean on the left from your perspective. And what it does, it basically loads the data from a address in that was passed by the kernel, and it queues the packet to the FIFO. The write control module is slightly more complex, as it has to manage the delays that might be, the stalls and delays that might be occurring on the receiving end. So we had to add first ring buffer capabilities to achieve the possibility to be capturing the data continuously, because obviously the buffer is finite, so we couldn't, I mean, if we had so much RAM that we could avoid to not have it, then the implementation would be much, much easier. But I will get into it later. And what it also does is stamping the pickup, adding timestamps and pickup headers to the data. So yeah. Also, as I mentioned, stalling and delays might be an issue whenever you have a receiving agent in this case. So there is a special construct that's called a skid buffer, and it's basically a smart register that just knows when to hold the value and when to pass it further down the pipeline. So simulation, of course, had to be done. Model sim was used for quick and dirty simulating and making sure that everything works as intended, and Signal Tab was used as a onboard hardware logic analyzer. So maybe more interesting part of the talk, give me some results. So one most obvious conclusion is that you increase your processing, you increase your clock frequency, you get more data being crunched. And this is best visible here, that probably the one most important graph that you should remember from this presentation is this one, where we can see that the lines are going down, which means that the greater the packet size, the greater the frequency and burst length, the less time it takes for us to compute to pass the byte through the capturing module. So, and you can see that for small values of packet sizes, the overheads are really visible. And yeah, let me jump back to the previous one. So this one just focuses on the doubling of burst length. So whenever we double the burst length, we get a 33% increase in processing speed. So here you have, on the edge of the slide, you have burst length of 4 words, and closer to the middle is one of 16 words. So even here, you can see that the overhead for small packages is visible. And yeah, and as you can see, for 1 kilobyte packet size, the time gets halved, for example. Yeah. One surprise, power consumption remained steady. So this was a big surprise to me when I first stumbled upon it. Apparently, later I discovered that I've been not using any low power and sleep states in the CPU. So and basically it seems like even though there was no code on the FPGA running, the consumption was the same as with FPGA processing packets at, for example, 200 megahertz. So one obvious thing, you turn off the Ethernet module, you lose some power consumption, so you gain some cycles there. And this also might have been caused by the fact that, well, this is an embedded device and it wasn't flooded with packets all the time. So the logic, even though it was processing on 200 megahertz, for example, it only did it for a fraction of the total running time, right? But then we would need to check if the SDRAM, for example, would handle such a throughput, etc. So now we go into more details. Yeah, in terms of resource utilization, it's pretty lightweight. I think it might be not visible here, but it just utilizes 3,700 logic ALMs, and most of this is taken by the auto-generated interconnects. And why they have to use interconnects, I will go into details in just a little bit, because this was the main hurdle that I had faced with this project. So yeah, maybe before conclusions. So the main issue here was that I could not turn on the FPGA to SDRAM bridge, which had 256 bits of RAM, of bus width, I'm sorry. And instead of that, I had to resort to using 2 AXI buses that one was for reading, one for writing. And this caused me much pain, and apparently Cyclone V or Cyclone 5, apart from being unsupported in newest version of Quartus, which I painfully experienced during this project, it also doesn't support the FPGA to SDRAM, no matter what you do. If you set the registers in the FPGA and some other things. So this is one warning for you. If you want to go down that rabbit hole, don't waste your life. So yeah, some conclusions. Maybe, yeah, let's not drag it over, but first of all, as I said, your mileage may vary, but it can be efficient if you know when to accelerate and what to accelerate and how. Yeah, of course, this talk is to tell you a little bit how. So one important thing is that the higher you ramp up your clock, the wider your buses, the longer your bursts are to a reasonable limit, the more, the less time you spend in, I'm sorry, I got somewhere else. So one more time. I showed you that you go up with frequency, bus width, and burst length, you get more throughput and better performance. That's basically it. And take bigger packets. So you're limited usually by maximum transmission unit, which usually it's 1,500, if I'm not wrong. And so I checked up to 1 kilo. And one important thing, this is a trivia maybe, but I compared it with the baseline. So I checked how it fares against the regular in-kernel processing on this particular board. And it seems like I was getting 16 times to 100 times less times spent in processing. But remember that kernel did all the filtering, etc. So it must be taken with a grain of salt. Yeah, also my company is going to, I mean, Tieto thinks to port this to more beefy FPGAs to see how it fares on servers. And of course, this is aligned with the goals of Carbon-Aware SDK and Green Software Foundation, which aim to reduce the, let's say, ungreenness of the business that we're working in sometimes. Future work. So what could be done here? So first of all, stress testing, packet floods, etc. If the board burns, then yeah, we've tested it to the limit. Of course, initially this was aimed to be TCP dump-like, but it turned out that implementing some features was just too time-consuming, and I didn't have enough time to do it. And of course, I was bogged down by issues like not functioning bus or hanging bus, even though I was using proper addressing and everything, because it turned out that Altera or Intel had a bug in Quartus 19.3 where the interconnect would be generated wrong, so I was addressing in bytes and they still were addressing in words, so the bus hanged and I didn't know why. Axie showed it perfectly, so one more reason to use Axie, not Avalon. Yeah, and I've been talking with Antmicro company about utilizing their Antmicro video board that has open toolchain, open hardware, but they're still using Zing 7000, so this is still some kind of vendor lock-in, but a sponsor, I mean, they released also a open source toolchain for Xilinx devices that's called Enclastra. So this might work. Of course, if there is some effort to port it to RISC-V, I would be very happy to. Yeah, so tentative plan of action is to avoid vendor lock-in and some troubles with, for example, not working buses and etc. Or port it to RISC-V and be your own, yeah, let's say, maintainer. So some acknowledgements. This work couldn't have been done with help of my colleague Sebastian, who is an expert in FPGAs. And basically, he told me why the bus was hanging. And we had some hours of contemplation why life has to be so hard sometimes with these issues. Matthias Becker for constructive criticism and support. Shimon, who is my brother, who encouraged me to come here and fight the imposter syndrome that sometimes kicks in. And of course, to all of you for teaching me how to do it, showing me this amazing topic, and yeah, and I think that's almost all. I'll leave some links. Yeah, I have written a paper on this. It's available on my website, and if you want to follow this rabbit hole, then you may. There is one good resource that I recommend, is this second link from the bottom. It's concerned with DE10. So it's slightly different, but it's still a good attempt at putting it all together. So yeah, call to action time. So yeah, what do you think? Do you think it is a good area of research? Should it be pursued, or is it important? And yeah, let's discuss it. So I think that's thanks from me.
Hi, I just did a quick in-my-head review of a Linux driver. You would probably be better off using the DMA allocator for your memory area, because that will give you both the virtual and physical address of the page of memory and will allow you to do cache maintenance on it. Because otherwise, I think you were doing probably something which wasn't very cacheable, and your memory read performance will go up if the CPU can cache the memory.
Yeah, I think that in this case, what I aimed for was to have a contiguous buffer, which would be just read once by the, I mean, FPGA reads and writes to the physical memory there, and the system just has to go through it once, I think, when it's just collecting the pickup file. But yeah, this might be.
It would certainly be if you're using a lot of memory, and the API is fairly easy to use and will integrate with reserved memory.
Okay, cool.
So
Thanks
you probably want to have a quick look at that, and it might just improve your the code and not have to worry about the virtual to physical mappings that can go horribly wrong in some systems. I have systems where the coherent memory does not live in the same place as the non-coherent. It's like, yeah, it makes life a lot difficult.
Okay, thanks for that.
Yeah, thank you. One question with regards to why. Like, why would I put the Ethernet into CPU rather than into FPGA itself, and do this stuff out there and then produce the output? And when we do so, like, is it just a simplifying thing so that the lesser knowledge needed to enter this stuff or something like that?
Yeah, well, good question. Here, I decided basically to use what's available. So if you were to do it, let's say, more efficiently, then of course having an FPGA which would be offloading, for example, doing a T and just sending some data, this would be a hardware solution. But yeah, I think this would be much feasible. So in this case, this project could be reused. For example, the hardware part, reused, just ditch the driver in this case. But it would require a special board, which in this case was not really feasible to me. So I just took what I have and I tried to make the most of it. So, but I totally agree that the best way to do it more efficiently would be, as you said, FPGA and just teeing the output through the capturing program. Then it could be accessed from the user space regardless of what is being done in the kernel networking processing. So yeah, I totally agree.
So I was wondering, how does it affect latency? Because you have to do that extra copy between the devices, so from the FPGA back to the CPU to actually use it.
Yeah. So again, that's, as I said, your mileage may vary, so that's important to measure. In this case, we don't really care about the performance here because we don't put the, I mean, we care about the performance, but we're not interested in getting these packets from the capture place. Like, they don't need to be real time. So in terms of processing via kernel, they will still go through it, and they will be just captured, let's say, in parallel. So that's where the FPGA, the separate FPGA solution is probably winning here. So yeah. And also, we want to measure this, right? So I had some experiments, but this was with GPU computing, where actually it's like until you go for big data, the overhead of transferring between CPU and GPU is usually quite big. So of course, depends on the hardware, architecture, and all other kinds of things. So yeah.
Let me get one question in, and then we'll let you back. You showed at one point the steps of kind of setting up the system, and you had to download the program with this IP link, etc.
Yeah.
Is that plumbing that you had to build yourself, or this already exists? Just send an object file to my network card. This is normal plumbing, or you created this plumbing?
Let me go back because I don't remember. Sorry.
Yeah, and you have one with numbers.
Yeah. I'll just go back there. This one, right?
This one, yeah. So this number 3.
Yeah.
Is this in order to do this, this already exists in the kernel, or you had to create this?
So this is in the kernel. It's using the XDP BPF capability. So I basically use it as a trampoline to just push the code where I want to. And that's why I didn't do it initially with the separate FPGA as well, because I wanted to leave a gate for possible eBPF pre-filtering, because it's so powerful that it might just capture, for example, packets that are, I don't know, some specialized protocol only. And we might not want to do it in hardware as it is blazingly fast. But for capturing and saving, then this solution bypassing the kernel entirely might be more useful. So this is all in the kernel already. You just need to enable eBPF and just install the iptools2 package and write a simple program that just and compile it using BCC compiler tools. Like this.
Thank you.
Yeah, thanks.
Yeah, in continuation of my first question, so like why? I would think then, okay, so I would probably have a kind of a workload when I have the setup pre-installed and I cannot interrogate somewhere between the Ethernet cable, my media, and the machine, then this particular solution, and you referring to the Avalon bus or the interconnection between ARM core and FPGA itself. So I would think of, okay, then to offload that, I would need to FPGA being somewhere around, and for a like real system, I would have some FPGA installed in PCI Express slot. Then it will be a latency that you neglected in the first case. But then the DMA solution would be perfectly well here, and it will be brilliant, to-go way with the FPGA here. The other way around is you mentioned the SDRAM slots, and there is actually a project, Mr. FPGA, for the old retro gaming, and they have introduced a SRAM extension board for the Altera boards, so we can use SRAM. It is much simpler. You don't have to mess around with DDR initialization process. It's a cabal thing, kind of thing. So yeah, it's probably a way to go. Thank you.
Thanks. So just maybe building on top of that, the RDMA, actually, as you said. Just DMA. Okay. But yeah, okay. I thought that, so you would like to have the FPGA in a NIC slot and just to, yeah, so we're talking about some bigger workloads here, right? Yeah. Okay, so good idea. That's all I can say about this.
All right. Anyone? Oh, you want to do? We're going to fight over who's going to ask the last question. Go ahead. Go.
It will be a really small one. The protocols, you said it's TCP.
Yeah.
What's about ICMP, because it's relative protocol to TCP? You can't do the things without that. And what's the level of capture? Is it TCP capturing, or you go to the Ethernet frames? What are you doing? And towards to Ethernet, you said it's MTU 1.5, the upper limit. Can we do the jumbo frames with it?
Yeah, sure. You can do whatever the size would you like to. I limited it to 1 kilo for now. But obviously, yeah, you could capture whatever size you want. This is also a good point for more measurements and better metrics in this project. Yeah, I think this answers. You capture raw data that's coming on the link. That's basically what you do here. So, yeah.
All right, then I'm going to use my power as a session host to ask the last question, and then we'll thank you again. The limitation that you had with the DMA and the DRAM. So before we all feel bad about all FPGA. So it's about the chip that you had, like it was an older chip, so a newer chip solved the problem, or it's what? Who messed that up for you? Who
Maintainers.
Can we blame? Okay.
Maintainers
software maintainers
are to blame, and first of all, poor documentation, as I said. or no documentation. I mean, the resources that are scattered around and not up to date, that happens. And of course, they write one thing in the spec, enable this and this and that register. I did it. I tried it on several versions of software. Doesn't work on the firmware. So yeah, seems like that's why I believe that trusting vendors on especially not latest and expensive boards might be a shot in the foot.
Okay.
So yeah.
Okay. So a different chip would not have had the problem, or
I think yeah.
More likely. Okay. Beautiful. So thank you, Jakob, for everything. And thank you for the remaining audience for sticking around to the end of the session. So I'm confident that we'll do this again next year. So maybe see everyone in 12 months. But certainly appreciate all the energy that went in from everyone. Thank you. Thank you so much. Oh yes, I'm sorry. And Milena and John in the back. You had to listen to all of our blather for 2 days. Thank you so much.